Hello, everyone. We will start in 1 minute. We invite you to introduce yourself, say hello in the chat if you want. And 1 more minute, and we will start with the official opening of session. Perfect. So welcome everyone to the third edition of the Weather and Society Conference. My name is Isadora Jiménez, and I'm an expert on science communication and service co-design working at Lobelia Earth. And I have the honor to open the conference as co-chair along with Carla Muni of the SEDA Working Group, which stands for the Societal and Economic Research Applications Working Group of the World Weather Research Program of the WMO. On behalf of SEDA, I would like to welcome you and thank you for your participation in this conference today. And the last editions were a great success in terms of participation and diversity of experts and practitioners around the globe, although we all appreciate the benefits of in-person conference, the networking it brings. We wanted to build on the model of a free, wait, what is it? Wait, we really want to be sure that everyone has the opportunity to participate, and to be able to do it online brings this opportunity, and especially because we all want to talk about the value of social sciences in the weather services domain. Before we start officially, we really need to say thanks to all the people that is making this conference possible. We all are volunteers, and we would not be here without the support of our organizations and all the people involved. And I want to particularly mention the World Weather Research Program that is strongly supporting the role of social sciences on its implementation plan, and Isha and Junjing from the Secretariat for all their help over the last year. Lobelia has provided support for the creation of our new conference website and with part of the management system of the conference. And I also want to acknowledge the efforts of the organizing committee, which includes Carla Moni, Jelmer Jering, Mahil Lammers, Evaristo Mapezza, Don Nelson, and myself. And of course, all the session conveners, speakers, invited speakers, and all of you, all the conference participants that we are making this possible. I'm really excited to note that we have over 800 people registered for this conference, and you come from more than 150 countries across the world. So we are really looking forward to the range of presentations and discussions and all your insights and all the different perspectives that you will be able to bring over the next 4 days. The last edition, we chose the Early Warnings for All initiative as the conference theme. And this year, the theme is Whole of Society Approaches for Weather-Ready Communities. And this is because, I would say the last 2 years, but it's quite a few more years that have been full of extreme events, from LA fires, the Dana floods here in Spain, the floods in Texas, Hurricane Melissa, and many, many other extreme weather events around the globe. And the greatest challenge is not on getting better forecasts, which is a challenge on itself, but on how to transform warning information into action. So really is about the social and behavioral dimension of these warnings. So early warnings, like the last edition, are at the core of all the themes. And we will be talking about it during the whole conference, but we wanted to emphasize the specific focus on the contribution of social sciences to the achievement of this goal, which includes communication, which was session 1, transdisciplinary approaches, session 2, social sciences methods in session 3, and inclusion in session 4. But the whole world is talking about AI, and we could not be an exception. So the final session, we will discuss also societal implications of the emergence of AI in warning services. So it has been a pleasure to put together this program, which we hope will be of value to this broad community. And now, after this, it's time for formal opening statements from the World Meteorological Organization representatives. And it is my privilege now to welcome Dr. Veronique Bouchette. Veronique is the Senior Director for the Department of Science, Services and Capacity Development at WMO. And prior to her role, she represented operational world meteorological centers on the WMO Research Board and co-lead a task team on exascale computing, data handling, and artificial intelligence. And before joining WMO, Veronique served as the Director General of the Canadian Centre for Meteorological and Environmental Prediction. So, yeah, I'll pass over to Veronique. The floor is yours.
Thank you very much, Isadora. It's really my pleasure to welcome all of you, colleague and researcher and practitioner and partners, really, from across the globe for the third edition of the Weather and Society Conference. Before I forget, I do want to thank everyone, the working group, the SARA working group, as well as I would like to extend the thanks to all of you that contributed time and expertise and commitment in making the conference possible. I know it will be a success. The number of participants that have been able to register is speaking of in itself in terms of the how pertinent this conference is for many of us. And given the number, and I think despite the fact that not everyone is nobody is in person, but actually because of the access that being a virtual meeting provides, I think it is able to reach so much more in terms of participants. So really, with the number of registrants, I think this is a real and truly global conversation that will happen over the next few days. Isadora mentioned that it's really important to bring the forecast to an action, and that has been the themes really behind and the motivation behind the working group and the conference that have been coming together. And it was really in the context of being impactful and understanding what leads for those forecasts to really be acted upon. But this conference today is different because the context in which it's actually setting is evolving very rapidly, both in terms of the driver from the hydrometeorological events that are continuing to manifest themselves and intensify in ways that we can really experience them and understand that we have to react and create the condition by which we can act on the forecast and beyond. But it's also an environment where AI is reshaping what is possible, both in forecasting and in communicating, and those forecasts and how to reach to individual and on the ground, as well as colleagues in decision position. And it's also a context where the drivers and the gap between the science capability and the societal impacts continue to exist and sometimes widen even because of those technologies that are now available and that can help in theory to bridge that gap. So I think it's very instrumental for that discussion to happen at this point. There is however, no denying that that fundamental element, which is to bring a warning to actually an action to be taken, remains nonetheless at the core of what the conference is about and continue to be the main element that needs to be addressed. We've seen many examples over the past year that we can collect, but I think certainly what happened in Valencia was a real demonstration of where this conference is needed and continue to be key in addressing some of the challenges across transforming a warning into an action, and why it is really not just a methodological challenge. We'll have many colleagues very happy to continue advancing this part, but it's also a systemic challenge in that it really brings that intersection between knowledge and how to react to an information. And that systemic challenge does require a systemic solution that integrates the physical and the social components. So we're really very much counting on the discussions and all the ideas that will come out of the conference to move forward, to move us forward in that sense. I do want to highlight and restate that the interdisciplinary perspective cannot be an afterthought. They have to be at the starting point of those systemic solution. The tendency to think that social science is really relevant at the end when it comes time to communicate the result, it's something that's can no longer be how we build effective system. We are recognizing, but we now need to act really to ensure that gender, that age, that language, disability, and socioeconomic status are all part and variables that are integrated at the beginning of the value chain and remain a consistent element that is being measured as well as much as the quality of the forecast. So this is really what the challenge remains, because transdisciplinary work, it continues to be very hard. It does require the ability to navigate ambiguity and recognize that different type of knowledge, life experiences is just as much important in how we address those challenges. So that's certainly much more than bridges that are established. We really need to see that as an institutional commitment, and within the context of WMO, that's a path that we support and certainly want to engage in. I do have to say a few words as well in the context of AI, because we no longer can ignore it. It certainly has many different aspects of where it can provide potential life-changing ways of addressing the forecast, the communication of the forecast, the engagement, the reach in terms of even making language available in ways that we would not have been able to support. And that can translate in having those actions, because we have now the much readily capacity to do so, but it doesn't come without a price, and it has to be underpinned by integrity and trust. In that context, strengthening both the science that we do, and through the science strengthening that the information that is transmitted is being relied on and with the right content. So there's many challenges that come with it. Within WMO, we certainly are positioning ourselves to have the proper technical guidance and governance framework that are associated with the value chain that we are responsible for, but at the same time, this also applies to AI, and we need to understand what that means. I think we're starting to have a good sense about understanding the application of machine learning in the context of prediction up to a point. But what it means in the context of that last mile, how do we evaluate that we have the right information and that it is reproducible, and more importantly, that it is equitable in terms of the innovation that it provides, and that it brings reach as much the urban centers as the rural one, and everyone that is connected or not, and that they have that we reach. Really, at the end of the day, they're the one that needs the most, that needed the most. So I cannot underscore enough the work that you do over the next 4 days, because it's going to provide us with a lot of guidance, information, and it will shape program over the next months and year, in the context of how to ultimately reach community. And we're committed to working with all member states in that fashion. I'm really glad to see that there is a very broad reach of the conference, and that we're able to bring everyone together in that content. So I'm going to leave you the space to actually do the work and do the discussion. But thank you very much for the opportunity to open and share a few of our thoughts and how to advance forward.
Thank you to you, Veronique, for your time and your kind words. So now it's time for our second statement, and it will be from Dr. Estelle de Koning. Estelle is the chief of the Weather and Societal Impact Research section, which supports the World Weather Research Program at WMO. She leads the current and new activities of the WWRP linked to WMO Strategic Plan and Long-Term Goal 3, which aims to start the research on timescales from minutes to months. And she is originally from South Africa, where she worked for the South African Weather Service until 2016, and as a chief scientist of nowcasting and very short range forecasting. And well, the floor is yours, Estelle.
Thank you very much. And thank you, Veronique, also for your kind words, for the wonderful work that this group is doing. So from my side, good day, colleagues, from wherever you are in the world. I see more than 100 people already online at the moment. So for some it's morning, for some it's evening, for some it's maybe in the middle of the day. And I hope you have a good day. From my side, as the chief of the Weather and Societal Impact Research section in the WMO, it's a privilege to welcome you to this third Weather and Society Conference, organized by the SARA Working Group of the World Weather Research Program. And I would like to acknowledge, as Veronique also did, the wonderful work that this group has done, also with the help of Isha, to organize this fantastic event. And you attracted more than 800 registrations. And as Veronique said, that in itself says it. There are so many people that are interested in this topic and want to take part in the discussion that will follow. So in this conference, we will be bringing together the scientific and the user communities to reflect on case studies and examples and best practices to ensure that weather and society meet in the middle. This is a space where science and society converge to shape a safer and more resilient future. I'm inspired by the vision of this conference, namely transforming cutting-edge research, including the use of AI, into actionable solutions that truly make a difference to all of society. This is really a great ambition, and I'm greatly appreciative of this wonderful vision for this next few days. The WWRP mission is clear that there is a need to advance impact-based forecasting and decision support systems that empower societies to anticipate, prepare, and thrive in the face of weather-related challenges. And previous speakers have already alluded to many of those examples in recent future. This is not just about predicting the weather, but it is about predicting the outcome, the impact, and reducing the vulnerability so that we can save lives. In the former president of South Africa, Nelson Mandela's words, he said, by fostering collaboration across disciplines and sectors, we can ensure that weather and climate services become a cornerstone of societal resilience and sustainable development. And this aligns also very well with the opinions of the Secretary General of WMO, Professor Celeste Saulo, who recognizes the importance of science that reflects diverse contexts and informs real-world decisions. Let us use this conference space in the next 4 days, 4 hours at a time, as a catalyst for innovative thinking and creation of partnerships. Together, we can turn knowledge into action and build a future where every forecast is a tool for resilience, and every decision strengthens our collective capacity to adapt. Thank you very much for your interest in this conference and being part of this transformative journey. I look forward to listening to these contributions on this very important topic of discussion in the next 4 days. Thank you very much.
Thank you to you, Estelle, for all your support over these years and these 3 editions now of the conference. And finally, Dr. Andrew Tupper, and I guess he would like to emphasize the links with early warnings for all. And Andrew has recently joined WMO to lead the early warning services section. He is a meteorologist with an extensive career at the intersection of high impact weather, public safety, and the international collaboration at the Bureau of Meteorology in Australia. He has held senior leadership roles spanning some of the most demanding areas of operational meteorology, from tropical cyclones, floods, fires, volcanic eruptions, tsunami warnings, and aviation forecasting. So bringing both scientific rigor and deep commitment to saving lives to each discipline. Andrew, the floor is yours too.
Thank you so much, Isadora. Look, it's a great pleasure to be here. I'd like to follow Veronique and Estelle's words just by talking a little bit about the research into operations piece that often causes us difficulty. And coming into this early warning services section in WMO has helped me reflect on many of the themes discussed in the first Weather and Society conference, which I attended, and where we are now. I just want to build quickly on 2 points. The first is, we might sometimes wonder if we make a difference. But last year, WMO's Extraordinary Congress of Members agreed new technical regulations for all members that are really amazing in their scope, thanks to the efforts of many people, including many people here. For those who haven't heard of these technical regulations, it sounds a bit dry, please take time at some stage to find out about them. We'll be talking about them a lot over coming months and years. Within these regulations, agreed by all members, we see clear evidence of the kind of research and operational thinking that I've sometimes despaired of achieving. I see understanding of cooperation, stakeholder relationships, mandates, sustainable operations, business continuity, quality management, training, continuous improvement, research, respecting structures, multi-hazard early warning systems that go even outside hydrometeorology, all of those things. But in these new regulations, there's above all a strong emphasis on community connection and the consideration of warning effectiveness. I could not have conceived of all of this passing into our regulations 10 years ago. It reflects a determined, sustained effort by research and operational streams in our disciplines to keep raising the bar. So congratulations to everybody here who was involved in that effort. And I know that some of them are here. In terms of the early warnings for all effort, this means that we now have a wonderfully articulated and agreed model to follow. That leads me to my second point, which is about early warnings for all. I think that when, like many people here, when early warnings for all was announced, it was a surprise, but it also came across as a big top-down, humongously funded effort announced by the UN Secretary General and a great global thing that we would be hearing about. And in that, there's a temptation to see early warnings for all as a top-down project, but it's actually not. For early warnings for all to succeed, it actually has to succeed from the bottom up. It has no dedicated funding. It's not managed as a project. It's a collaboration between agencies, countries, and people. It's a global movement that can only succeed through the power of collaborative bottom-up partnership-driven science and operations. And the pace of the success of the movement depends on a very large extent on all of us, on the relationships that we forge, the listening that we do, and the extra kilometres, not just miles, that we do to help bring cutting-edge thinking into operations for the good of the people. So this conference will be articulating the next future of warnings. We know that through looking at how our present is shaped by the work of the past and by the quality of the people present here this week. So like my colleagues, I'm really looking forward to listening and understanding what is going to be coming through into operations in just a few years' time. Thanks everybody for your time, and I wish everyone a successful conference.
Thank you very much, Andrew, and thank you, Estelle and Veronique, for your kind words and the opening. And to wrap up this opening session, we wanted to have an invited talk by Professor Iracema Alcantara-Ayala. Unfortunately, she finally could not join us in person, but she has been kind to be sending a recording, and we will be playing it. And Iracema is former director and current professor at the Institute of Geography of the National Autonomous University of Mexico, where she leads research on disaster risk reduction, promoting integrated approaches to risk. She has served on multiple international boards, including the Scientific Committee of Integrated Research on Disaster Risk of the International Science Council. And now she is a member of the Scientific Steering Committee at the WWRP. Through her career, she has advanced integrated disaster risk science and strengthened the science policy interface globally. And she has been really supporting the SERA working group on our endeavor to bring all these topics to you. So now we'll put the recording.
Good day. Thank you very much to the conference organizers for the kind invitation. I regret not being able to join you in real time, but I am pleased to contribute through this recorded presentation. Early warning needs early understanding. Weather extremes do not become disasters by surprise. They become disasters when warnings arrive too late, are not understood, or cannot be acted upon. Natural hazards are detected by instruments. Risk is understood by people. Early warning systems fail not because forecasts are wrong, but because warnings do not align with lived realities, institutional capacities, and decision-making contexts. Early warning is therefore not only about detecting hazards at an earlier stage. It is about understanding risk earlier before an alert is issued. This presentation argues that early understanding of risk and context is the foundation of effective early warning and meaningful action. Over the last decade, we have seen remarkable progress in early warning systems. Advances in observation technologies, numerical modeling, and communication platforms have significantly improved our ability to detect hazards and issue timely alerts. This progress underpins global ambitions such as early warnings for all, which aims to ensure universal access to warning information. However, despite these advances, disaster losses, both in human and socioeconomic terms, continue to increase. Importantly, these losses are not evenly distributed. They excessively affect populations already facing structural vulnerability, limited institutional support, and constrained response options. This is telling us something crucial. The problem is no longer only about whether a warning is issued on time. It is about whether that warning makes sense within specific social, institutional, and governance contexts, and whether people are actually able to act upon it. This is where the need to move from early warning alone to early understanding becomes critical. Early warning systems are fundamentally designed to answer a temporal question: when a potentially hazardous event is likely to occur. This is essential, but it is only one part of the risk equation. Early understanding, by contrast, addresses a different set of questions. Who is exposed, why certain groups face higher risk, and what capacity people and institutions have to respond meaningfully when a warning is issued. This understanding requires attention to how risk is produced and accumulated over time, how vulnerability and exposure are socially differentiated, and how decisions about risk are governed across institutional and policy scales. The core proposition of this contribution is therefore straightforward but consequential. early warning can only be effective if it is grounded in early understanding. Without this, even technically robust warnings may fail to translate into protective action or risk reduction. Across hazards and regions, we see a recurrent pattern. Forecasts are often technically sound and warnings are issued on time, yet action is delayed, partial, or absent, especially among those already facing structural vulnerability. This points not to a failure of forecasting, but to a gap between warning and understanding. Conventional approaches to early warning are grounded in a set of assumptions that have been both productive and limiting. The dominant model assumes that improvements in data, forecasting skills, and communication technologies will naturally lead to better decisions and safer outcomes. It also tends to assume that once an alert is clearly issued, people will respond in predictable and appropriate ways, and that information flows in a largely linear manner, from scientific experts to decision makers and then to the public. What this framing often overlooks are the social realities in which warnings are received. Vulnerability and exposure are socially differentiated. Trust in institutions varies widely, and people face very real constraints related to livelihoods, mobility, housing, and legal or political status. These factors fundamentally shape whether and how a warning can be acted upon. Recognizing these limits does not mean rejecting technical advances in early warning. Rather, it highlights the need to complement them with a deeper understanding of risks, governance, and social context. Building on these limitations, I propose a reframing of early warning systems as socio-technical systems. This means recognizing that early warning systems are not simply collections of sensors, models, and communication channels, but systems that are embedded within social relations, institutional arrangements, and governance processes. Warnings are interpreted, trusted, and acted upon or not within these broader contexts. They interact with decision-making practices across scales, from national authorities to local governments and households, and they are inseparable from longer-term processes of risk creation and risk reduction. The key shift, therefore, is from a narrow focus on warning delivery toward a broader focus on risk-informed action. This reframing does not diminish the importance of technical excellence. Rather, it situates technical capabilities within the social and institutional conditions that, at the end of the day, determine whether early warning leads to meaningful risk reduction. The term people-centered is now widely used in early warning discourses, but it is often applied loosely or reduced to participation at the end of the warning chain. Here I use the term in a more precise sense. A people-centered early warning system recognizes that risk is socially differentiated and that people experience and respond to warnings in very different ways, depending on their exposure, vulnerability, and access to resources. It also means engaging seriously with local knowledge, experience, and memory, not as anecdotal inputs, but as essential components of how risk is understood and managed over time. Being people-centered requires asking who is actually able to act on a warning, who is constrained, and why. Without this, warning information may be technically accurate, but practically unusable. In this framing, people are not the last mile of early warning. They are integral components of the system itself. Despite growing recognition of the importance of people-centered approaches, early warning systems often remain fragmented. Different components of the system operate in parallel rather than in connection. Scientific knowledge about hazards is frequently decoupled from social understanding of vulnerability and exposure. National or regional warning protocols may not align with local decision-making realities. early warning activities are often separated from longer-term risk reduction efforts, and institutional actors and communities are not always meaningfully connected. The consequence of these gaps is not the absence of warnings, but the failure of warnings to translate consistently into timely, appropriate, and equitable action. Fragmentation limits the effectiveness of even technically advanced systems. This persistent lack of articulation is the central challenge that motivates the framework I am proposing. In response to these persistent gaps, my colleague Anthony Oliver Smith, Emeritus Professor in Anthropology, and I proposed the concept of articulated people-centered early warning systems. By articulation, this do not simply mean coordination or information sharing. It means the active and ongoing connection between different forms of knowledge, different institutional levels, and different societal actors. In an articulated system, hazard and forecasting information is explicitly linked to an understanding of risk, vulnerability, and exposure. Governance arrangements are aligned with how decisions are actually made across scales, and community knowledge and experience are treated as integral, not supplementary. Crucially, these elements do not operate in parallel. They interact continuously, shaping how warnings are interpreted, trusted, and acted upon. Articulation is therefore not an additional component of early warning systems. It is a property of how the system functions as a whole. In conventional early warning practice, risk communication is often treated as the final step in a linear process. Forecasts are produced, alerts are issued, and information is transmitted to users. In an articulated people-centered early warning system, communication is understood differently. It is a process of sense-making, in which warning information is interpreted, negotiated, and acted upon through social interaction. Meaning is shaped by past experience, collective memory, levels of trust in institutions, and everyday decision contexts. Effective communication, therefore, is not simply about clarity or speed. It is about whether warning information maps to locally meaningful action options. This requires ongoing interaction before, during, and after hazardous events, not only when an alert is issued. This reframing is central to translating early warning into risk-informed decisions and sustained risk reduction. One of the most consistent findings across disaster risk research is that the impacts of hazardous events are not evenly distributed. The structural vulnerability shaped by social, economic, political, and institutional processes strongly conditions how people experience both hazards and warnings. This means that the same warning can lead to very different outcomes. Some people may be able to evacuate, secure assets, or adjust livelihoods, while others face constraints related to mobility, employment, housing quality, or access to institutional support. These constraints are not individual choices. They are structurally produced. If early warning systems are not grounded in early understanding of these differentiated conditions, they risk reinforcing existing inequalities. In such cases, early warning may function as a technical success, but as a social failure. Recognizing structural vulnerability is therefore not an ethical add-on. It is central to the effectiveness of people-centered early warning systems. Landslides provide a clear illustration of why early understanding matters. In many mountainous and peri-urban regions, landslide early warning systems are technically robust. Rainfall thresholds, slope monitoring, and alert protocols can indicate heightened danger with reasonable accuracy. However, landslide impacts often recur in the same locations and affect the same populations. This is not because warnings are absent, but because exposure and vulnerability are deeply embedded in long-term processes, such as land use planning, housing availability, informal settlement patterns, and limited livelihood alternatives. For many residents, acting on a warning is not straightforward. Evacuation may mean losing income, leaving assets behind, or having nowhere safe to go. At the same time, early warning is frequently weakly articulated with land use governance and risk reduction policies that could address these underlying conditions. This example highlights the central argument of this presentation. Without early understanding of how risk is produced and constrained, early warning alone cannot prevent recurring losses. When early warning systems are articulated, practice changes in several important ways. First, understanding social vulnerability is not added after the warning is designed. It informs how warnings are framed, communicated, and acted upon from the beginning. Second, risk communication becomes an ongoing process of interaction rather than a one-off alert. This strengthens trust, improves relevance, and helps align warning information with realistic decision options. Third, articulation clarifies institutional roles across scales. National forecasting agencies, local governments, and community actors are not operating in isolation, but as interconnected parts of the system. Finally, early warning is no longer treated as a standalone activity. It becomes explicitly linked to land use planning, preparedness, and recovery processes that address underlying risk drivers. This perspective aligns closely with the vision of early warnings for all, particularly its emphasis on people-centered early warning. However, it also suggests a refinement of how that vision is operationalized. Articulated early warning systems shift the focus from simply expanding coverage, ensuring that everyone receives a warning, to strengthening people's ability to act on it. This requires integrating social and institutional dimensions across all components of early warning systems, not treating them as separate or secondary concerns. From a policy perspective, this means investing not only in early detection technologies, but also in early understanding of risk. It means embedding early warning within broader governance and development processes, including land use planning and social protection. And it means evaluating early warning systems by their contribution to reduce risk and losses, rather than by the number of alerts issued. To summarize, early warning systems are essential, but they are not sufficient on their own. Without early understanding of how risk is produced, differentiated, and governed, even timely and accurate warnings may fail to reduce losses. Fragmentation between disciplines, institutions, and societal actors remains a key barrier. Addressing this requires moving toward articulated, people-centered early warning systems that actively connect scientific knowledge, governance arrangements, and community realities. At the end of the day, the effectiveness of early warning should be judged not by the sophistication of forecasts or the number of alerts issued, but by whether warnings are understood, trusted, and translated into meaningful action that reduces risk.
Yes.
This perspective points to a clear call to action across domains. For science, it means advancing truly integrated research that brings social and physical sciences together from the outset. For policy, it means embedding early warning within broader governance and development processes rather than treating it as a standalone technical function. For practice, it requires sustained engagement with communities, recognizing lived experience, local knowledge, and real constraints on action as central to how early warning systems function. Bridging science, policy, and practice in this way is essential if early warning systems are to fulfill their promise, not just to warn, but to reduce risk in equitable and sustainable ways. This graph summarizes the framework I have discussed. At the center is early understanding of risk, how risk is produced, differentiated, and governed. Surrounding these are 4 domains that are often treated unconnectedly in practice, but which must be actively connected in an articulated early warning system. Hazard and forecasting knowledge interacts with social understandings of vulnerability, with governance arrangements that shape decisions, and with community knowledge and capacities. Risk communication operates across the entire system as a process of sense-making, feedback, and learning over time. The key point is that effectiveness does not come from strengthening one component in isolation, but from how well these elements are articulated. This articulation is what enables early warning to translate into meaningful, equitable risk reduction. In closing, let us return to a simple but powerful truth. Early warning only saves lives when it is grounded in early understanding. Data alone is not enough. Technology alone is not enough. It is the depth of our insight into risk, context, vulnerability, and human behavior that transforms signals into action and information into impact. As we move forward, may we continue to invest not only in faster systems, but in deeper knowledge, not only in detection, but in interpretation, not only in warning, but in trust and preparedness. When understanding comes first, warning becomes meaningful, and lives and assets are safe. Thank you very much for your kind attention.
Wonderful introduction. And now it's time to hand it over to Filip Bukowski from Medarian to start with session 1 on what makes the communication of early warning systems successful, which is the session convened by Filip Bukowski, Gilbert, Siame, and myself. Thanks. That's all for me. Filip?
Thank you, Isadora, and welcome everyone. It's really great to see such a huge participation today. I can see 130 people at this moment. So yeah, well, today's session, the first session of the conference, is what makes the communication of early warnings or early warning systems successful. So it is all about exploring the effective communication of weather warnings on of short-term level and seasonal and sub-seasonal levels. We looked at it through the visual clarity, language accessibility, uncertainty messaging, and other diverse dissemination channels. So we believe all of these elements contribute to early warnings for all initiative and how we ultimately communicate the warnings. But we explore them not only through the technicalities of the system, but also through the lived experiences, through research and knowledge across the world, across different countries. So the first part of this session will begin with a panel, and the panel will be on hurricanes and severe weather communication. So over 2024 and 2025, the hurricane season put the Caribbean region especially through a catastrophic power and rapid intensification of the storms like Beryl and Melissa. We saw scientific triumphs in the ability to forecast the systems, but we also faced the reality of what happens when the devastating storms hit the islands. Today, we're looking beyond meteorology. We are focusing on the vital lifeline that connects the forecast to the weather center with the people, stakeholders, and families who sometimes on a very short notice need to evacuate. And that lifeline in between the communication center and the people on the ground is in fact communication. Our planet today explores pressing challenges. We have growing scientific models that are more and more advanced, but sometimes we have difficulty to translate the outputs of those models into the clear communication for everybody. So our goal is to share operational lessons and strategic insights to ensure that every person, regardless of their geography, language, or internet access, receives timely, understandable, and actionable information under the early warnings for all framework. So for the panel, there will be 4 panelists with me to unpack all these topics. So in order of the presentation, we'll have first Gerard Tamar from Granada Airports Authority. Then we'll have the Kathy Ann Caesar from Caribbean Institute for Meteorology and Hydrology. Then we will have Eben Thompson from Meteorology Service of Jamaica. And finally, Haley Anderson from Caribbean Meteorological Organization from Trinidad and Tobago. We'll have quick flash presentations, 5 minutes per person, so really quick, but then we'll follow with the discussion and questions from the audience. So if you have any questions, please put them in the chat, and we kindly ask that anybody who is not the speaker will mute themselves for the duration of the presentations. So we'll be taking the questions during the discussion. So with that, I give the floor to Gerard Tamar, once again from Granada Airports Authority. Gerard, the floor is yours.
Good afternoon. Let me just share my screen. Make sure. Okay, good afternoon, good morning, good evening, good night to everyone, wherever you are. We're in the Caribbean now, so it's nice and sunny afternoon. Hope everyone is doing fine. 2024, we had the unfortunate experience of being impacted by Hurricane Beryl. And we are here now today just to show some part of our experience and what happened. Well, I know we have an international audience, so just to give a little insight of where Grenada actually is, if you look at this the screen, you can see we are situated just around a little under 200 miles on the northeastern tip of South America. So that's actually about just off the coast of Venezuela. Okay, and we say Grenada, but we are the state of Grenada, which comprises of 3 islands. The mainland is called Grenada, and 2 smaller islands, Carriacou and Petit Martinique, with a grand area of 133 square miles. Now, that may be just the size of some of your cities, but it's our island. A very small population of 110,000 persons, okay? And we are located, if you want to know the exact location, latitude 12 degrees north, 61.7 degrees west. So that puts us at the western edge of the Atlantic Ocean. Okay. Okay. Now, so as I said, we were visited by Hurricane Beryl 1st of July 2024. And we all know Hurricane Beryl was a record-breaking system. It was the earliest Category 5 system on record, and it impacted us with winds of 150 miles an hour. Okay? Minimum pressure dropping all the way to 950 millibars. We recorded our highest 24-hour rainfall during the passage of Beryl, 261 millimeters. Okay? And it led to 3 deaths and 98% destruction of infrastructure and all other buildings on our island of Carriacou. And that was a sight to behold. But what happened June Beryl? Now, just to give a little insight of how we operated and seeing that we're on the whole theme of communication. Now, first of all, our service communicated with our population in a particular way. Now, at this onset of every hurricane season, now in the Caribbean, the Atlantic hurricane season runs from the 1st of June. So at the onset of that, from the 1st of June, we start issuing a special media output, which will look especially at the prevailing weather. For example, we follow what the National Hurricane Center produces. They produce a tropical weather outlook bulletin, and that comes out 4 times a day. So what we do, we use that basically as a guideline. And for the entire hurricane season, we will issue something very similar to our nation. So every wave, every area of disturbance, every name system that is developed is noted there. So once you are following us, you are well informed from the 1st of June to the 30th of November. So when Beryl came knocking, okay, we did what most of other Met offices would do. You know, you ramp up staff, and you send your like we had forecasters going to the National Emergency Center to brief the disaster personnel, the law enforcement personnel, the utility personnel, all who would gather to make decisions for the nation. So that when Beryl came and we went under hurricane watch on the 29th of June, okay, it would have been no surprise to the nation because they were being informed and they were being fed with this information before. And living in the Caribbean, where we are exposed to this sort of hazard on a yearly basis, the population now look forward to it, unfortunately, but it's a way of life. So the population was informed. So we went from hurricane watch to hurricane warning in the same day. Now, once we were under these conditions, as a service, we started now issuing bulletins specifically for that system. And this is apart from our normal information, which would give our general weather forecasts and things like that. So we would spend a lot of time on develop these products specifically about the pending hazard, which was Hurricane Beryl at the time. Okay? So from when we went under hurricane warning, which will mean that hurricane-like conditions are expected within the next 36 hours. Now, during that time, once that is issued, during that time, the island goes into lockdown mode. All schools are closed, businesses are closed, only essential services are up and about. Okay? And going hand in hand with that now, we started doing regular TV and radio updates to the nation every 3 hours most of the time. Okay? And you can see from the picture here on the screen, you see that 3-man panel. The person on the right is Cassia Johnson, one of our forecasters, and she was tasked with the responsibility of updating the nation. Okay, and
Sorry,
she
Gerard,
was
we
fed.
just have to move on to the next person. We will have a time for the questions later, but as I said, we have 5 minutes per speaker, so we'll now move on to Kathy and Caesar for her presentation. And if we have specific questions about the process, we'll be happy to do that during the discussion. So thank you very much for this interview so far, and we move on to Kathy Ann.
Thank you. Just need permission to share. Jared, you might have to stop sharing.
Yeah.
I still cannot share. Oh, there we go. Thank you. Good day all. Kathy Ann Caesar from the Caribbean Institute of Meteorology and Hydrology. As we have this limited time, I just wanted to introduce you to the impact of CIMH on early warning over the last 20 years. CIMH, since 2007, when we were first asked by our Caribbean Disaster Emergency Agency to give briefings on analysis of Tropical Storm Dean, we got involved with actually briefing our stakeholders on tropical systems and particularly severe weather. This actually is in collaboration with with our mandate, which actually serves our training and research community to serve our stakeholders to advise them of impending weather, and our 16 member states, which are our stakeholders. We became a partner with SEDIMA's rapid response team, and so we collaborate on weather forecasting and disaster management involved during and after the process of the impending system. The briefings include updates on particular systems, possible motion, potential impacts, a diagnostic of satellites, images and analysis, as well as model data input. Our expertise as a center of excellence is an extremely important asset to our member states before, during, and after a system. This is in line with our strategic regional frameworks. We have collaborated with and continue to collaborate with our international and regional stakeholders to, one, work with WMO's early warnings for all systems, as well as the SEDIMA and 5C's initiative framework goals. We have embedded meteorological models which introduce risk flows for flooding, hurricane, severe weather, heat waves, and droughts. And we steadily actually strengthen our community resilience as we go forward. And this is totally in correspondence and coordination with our response and protocols across our regional mandates. More importantly, we have in process of developing a Caribbean multi-hazard early warning systems attribution. This is where we are now looking at harmonizing climatological information, geological information, hydrological information, as well as marine, to actually provide a broad-based multi-hazard early warning system across the region, integrating policies, new skills, and thinking partnerships across the region. Importantly, and I want to stress this, is particularly in light of the theme of this particular workshop, is looking at cascading multi-hazard systems should be seamlessly cascaded, across connecting multi-sector systems, particularly introducing those socioeconomic impacts. As we should realize, and it was discussed in the previous presentations, how our socioeconomic well-being, basic or situation does feed into the impacts of and risk of multi-hazard systems. And so this is part of our initiative as we go forward. And I'll be happy to share this presentation with you on that initiative. So one of the things that we do, as I stated before, is that during hurricane season particularly, but even outside when there is a severe weather event, we provide analysis of any system, hurricane, severe weather event, doing directly with the SEDIMA partners. We look at hydrological, geological, and meteorological impacts and climate impacts, and we present these discussions with them so that you can understand what is happening, as I said, prior, during, and after an event. And we see here we have an example of Hurricane Melissa, which was, again, really not groundbreaking, but a really hazardous event that was, as our colleague would talk about after this presentation. We have introduced various models starting all the way back from 2007 onwards. And these models have actually developed across regions, and particularly we're becoming having more high-resolution models and actually expanding these models not only to meteorology, but we have a dust model, climate models, as well as hydrological and flood models as well. Some of these models have been actually extremely helpful, particularly in 2010 with the passage of tropical storm hurricane at that time, Thomas, after the earthquake, and we needed to have that kind of giving a very good example of how we can have these cross-hazardous events impacting one on top of another. And we were able to provide model outputs for that. And just running through these examples, we had 2013 Christmas Eve event across St. Lucia and Dominica, where a number of people died, but we were able again to provide again, update and model outputs for this one. In 2016, I would say the passage of Hurricane Matthew on the outskirts of Haiti saved lives, as many people will be able to evacuate it once we send out those alerts to the people of Haiti. And of course, Hurricane Beryl and Hurricane Melissa, we were able to provide that kind of information to our colleagues in Jamaica as well prior to these two events. We are now embarking on also climatological models, looking at our seasonal hurricane forecast, but also we're looking at severe cyclones, coastal flooding, heat waves, and drought forecasting as well. We partner consistently with our partners, also the risk-based forecasting, impact-based forecasting, and CAP alerts. Education is our hallmark, and we have over 200 or more forums in terms of training, workshops across the region, particularly in severe weather, and we continuously do this over the years.
Thank you,
Of course, we
Kathy-Ann.
cannot go to AI. I was go ahead with it right here in AI, and we could go ahead and answer that in the forum. Thank you.
Absolutely. This is very comprehensive, and there's a lot of development we can see. So we'll discuss certainly further. If you have any questions, please pop them in the chat. Gilbert is actively looking at them. Now we're moving on to Evan Thompson from the Service of Jamaica. So Evan, the floor is yours.
Okay, here I am. Thank you so much for allowing me to speak, Filip. And I'm really going to be sharing some of the experiences that we had in dealing with Hurricane Melissa in October of 2025, just last year, just really about less than 6 months ago, when we had to have that system move closer and closer to Jamaica and, of course, over us. So we learned a few things as we went through this hurricane. I want to point to 5 things in particular that I think we must bear in mind when we are communicating about these tropical cyclones, and Melissa showed this to us. The first one is timeliness, because we must always keep ourselves up to date with the latest information, and that's the information that we must also pass out to our publics in a really timely fashion. So we do need to ensure that we are kept up to date with what is happening. And I learned this the hard way in one of those press conferences that was taking place for Hurricane Melissa. Actually went to the press conference, briefed with the latest information, yes, but the press conference itself was delayed. And then by the time I was expected to present, some updates had taken place that I was not aware of. And so I learned the hard way, because there were others who were calling me out on that afterwards. And of course, well, luckily I had the opportunity to make the correction as we went forward. But being timely is one of the things that we must bear in mind at all times. Secondly, the timing of our communication is also important. So we do believe that when we are sending out our messages, when we are informing our public, we need to coordinate with whatever other agencies are involved in this whole process, so that what ends up going out ensures that there is no mixed communication or mixed messaging that is going out, but everyone is consistent in what is being disseminated. We also have to ensure that we consider the timing of the messages to ensure that we do not reach people at times when they are not able to take action. So sending out a message in the middle of the night sometimes that is requiring that people evacuate is sometimes not the best approach, but instead we send out such a message earlier than that time, just to ensure that there will be information passed out. And then we don't send everything at one time, but as we get additional information, we add that moving forward. The third word is transparency, because we must ensure that there is access to sources of our information. And when the public feels that you are giving them as much as they need, they then begin to trust you. They build an understanding of what is happening, and they also build a relationship with you and are able to trust a lot more of what you are saying. We also have the opportunity in some of these press briefings to explain what are some of the difficult concepts that we're dealing with. And we have to ensure that we remain accessible and available to the public. In that way, they know that you have their backs and they will also support you in what you're trying to communicate in passing that message out. The tone of our messaging is also another important thing that I think we need to bear in mind, because sometimes you have to adjust the way you communicate your message in order to get the best reaction or the best actions out of these persons that you speak to. So the tone sometimes has to change in order to communicate the complexity or maybe the urgency of the message that you're carrying. And then finally, I just wanted to point out that we have to use all sources of technology, all ways of communicating to our public, all ways that we can make sure that they do get the information, whether we're using emails or we're using websites, or maybe it is apps, weather apps or other applications on our phones. We might be using other kinds of technology. There might be town criers, people just going out into the streets and really carrying the message. But we have to ensure that all modes of communication are utilized. So those are my 5 T's: the timeliness, the timing, the technology, the tone, and of course the transparency that we all have to bear in mind when we're communicating. Thank you.
Thank you so very much. I think it's a great message and a great tagline, 5 T's for communication. So we'll definitely explore that further within the discussion itself. So thank you very much for this. And we'll move to the final short presentation from Haley Anderson. Hopefully we can get that okay. Yes, I think we can see the presentation. So the floor is yours.
Okay, thank you very much. So I am presenting on the results and outcomes from a workshop that was held in January 2026 in the Caribbean, in Trinidad and Tobago, to be precise. What I will touch on is some of our communication gaps in Caribbean multi-hazard early warning systems. I will introduce the approach that we decided to use to address the communication gaps. I'll point out some of the outcomes and recommended actions stemming from the workshop, and we'll also prioritize the opportunities that could be taken up, and also highlight some key takeaways for the global early warning system community. So the background is that forecasting capacity and skill in the Caribbean and the globe has improved significantly. However, there is growing recognition that the effectiveness of early warning systems depends increasingly so on how information is communicated, understood, and acted upon. So we organized a regional workshop aimed at strengthening coordination and mutual understanding, and brought together National Met Services, National Disaster Risk Management Offices, Government Information Services, and the media to interrogate the communication chain. We recognized that there were several systemic challenges in terms of effective communication. There are fragmented communication pathways across the NMHSs, NDRMOs, Government Information Services, and the media. We also recognize that traditional media has experienced limited and unequal access to timely and authoritative information, to official channels, and of course to expert voices who can help to augment, clarify, and verify official communications. And these would create gaps that could be exploited with the advent of digital platforms that help very much so to amplify good information, also works to amplify misinformation, and very often can lead to the provision of conflicting reports. So our approach was to work as a collective: the Caribbean Meteorological Organization, Caribbean Broadcasting Union, Caribbean Disaster Emergency Management Agency, the WMO, and UNDRR. Under the Cruise Caribbean Project Phase 2, we worked together to build on the work that was already being done in the Caribbean region. Our key design principle was to have a structured learning journey towards understanding the different roles and responsibilities of the different actors in the early warning communication chain, but also to understand the connections across agencies. Then we also looked at a couple scenarios towards mapping the information flow, but also the identification of bottlenecks and some near-term fixes. We also introduced participants to practical tools and messaging templates, emergency broadcasting protocols, and model disaster preparedness plan for media institutions to help them strengthen their communication and mutual engagement with each other. And some of the key outcomes and recommended actions coming out of the extensive discussions that emanated out of the workshop was that they were very quick and eager to recommend the use and the expansion of the use of rapid multi-channel communications, such as WhatsApp. They also recommended having a unified voice comprising of National Met Services, National Disaster Offices, and Government Information Services through enhanced and strengthened coordination between them to have a unified voice and unified position in the provision of public information. They also emphasized the building of trust-based partnerships during peacetime, that is before the crisis emerges, developing activation criteria and ready-to-use templates, especially for the media, so that they can utilize that information to provide rapid early warning and actions to the general public, even in the face of uncertainty. They also strongly recommended advancing impact-based forecasting and warning, and of course, complementary common alerting protocol implementation to increase the quality of the information that is accessible to the media, but also accessible to the general public, and using simple jargon-free language in public communications. In terms of actions to be taken and recommended, they also recommended embedding service-linked recommendations in the actions. So instead of saying, go to evacuation shelter, or go to an emergency shelter, you can say, go to the emergency shelter located at X location, who will provide you accommodation, food, etc., etc. So it gives motivation. They also suggested strengthening joint public education and, interestingly, involving the highest levels of leadership, taking lead from the Jamaica experience with Hurricane Melissa, where the Prime Minister was deeply involved in the public communication. So the priorities going forward that the participants identified is that, well, a few countries wanted to conduct a similar type of activity in their own country. And we are looking towards supporting St. Vincent and the Grenadines and the Turks and Caicos Islands in the pilot targeted national workshops under the Cruise Caribbean Project 2.0 to operationalize the media engagement mechanisms by the Met Services and disaster offices, but also to jointly develop these emergency broadcasting templates and activation protocols. The idea is to move towards implementation and not replication of the workshop. And key takeaway for the regional and international organizations is to increase the effort to implement impact-based forecasting and warning and common alerting protocol. Global takeaways stemming from this workshop is that the forecast scale does not equal warning effectiveness. I think we've heard that before. Communication failures are often procedural and not really technical in nature. Consider the media as your operational partner in the warning value chain. These templates and pre-agreed protocols can help mitigate crisis friction, and that impact-based but culturally sensitive communication helps to strengthen trust. Integrated traditional, digital, and informal networks really do help increase the reach of your early warnings. I would like to leave with this key takeaway in that strengthening communication pathways is not an add-on to early warnings for all, but it is foundational to its success. Thank you very much, Filip.
Thank you very much, Haley. I think this point really summarizes well the experiences across our different speakers. So I can see that there are some recurring themes. I can see that there's a lot of questions also in the chat to all of you. But before we move on to the questions, I have a bit more general discussion starter, so to speak. So my question would be, that when I first read all of your abstracts when they were submitted, I thought that there is this recurring theme about the tension between the scientific accuracy and public comprehension. So a question to all of you, but also any of you, is what do you think is the single most effective strategy to translate this complex meteorological knowledge and jargon into actionable language? I think that's something we can ask. So if any of you wants to answer this. I can see the unmute from even yes.
Okay, thank you very much. Interesting question. And yes, that is something that we all have to deal with from time to time. Sometimes the information, they might say make it simpler, but when you think about the words, how do you simplify some of the terms that just seem so simple to you? You know, they just seem like they already communicate everything, and moving away from that could maybe communicate a different message entirely. So it's important, first of all, that we understand what these things actually mean. And then in communicating it, use the kind of language that we know our audience will understand. Of course, if I'm speaking to the technocrats or even the politicians, the persons who are in charge of our government, and then again, if we're speaking to the persons who are on the street, the way we communicate and the words that we use when we communicate would change. And so we must understand it so that our communication may be appropriate in whatever scenario we're placed in. So I think that is the primary thing, understanding it well, and then being able to use your own language to meet the needs of the persons that you're speaking with.
Right. Very good insight. Thank you.
If I can add
yes,
to
yes.
what I want to say. Coming out of our workshop, it really highlighted, I should say, that no organization is an island. The Met Service may not be able to translate the information, and they may not have the skill in-house to translate the information, I should say. This is where having a strong working relationship with the media and other public information related partners can really help. One of our key recommendations, as I just presented, was to strengthen that operational partnership with the media. And I think that is one of the key ways that this question can be addressed. Thank you.
Thank you very much. I think that ties also with that multi-channel communication that Jared started talking about. Again, apologize for having to interrupt. But yeah, I think it ties quite a bit with that point. You started talking, Jared, about you have a spokesperson specifically for the event. Did you find that it helps to communicate better with the public or the stakeholders?
Yes, absolutely. Because what happened too, at that time, remember the population is stressed because they are anxious. So having a familiar face, a particular face, is actually helps. Okay. Another important thing too, the whole issue of public education is paramount. The populace have to understand what hazards they face, and they have to also learn the language used. So you have to continually be educating them, and it's something you can do in the downtime. Okay? And it will take a few years, but eventually you will have a very, very educated population eventually. So then you can speak, so that we can speak at a certain level, so that it will be comfortable for us and inherently comfortable for the population. Okay.
Right. Thank you very much for that comment.
Can
Yes,
I add
Kathy,
really quickly?
yes.
Other thing that we found coming out of 2017, where we had a number of storms, there was a study, and they understand the importance of societal impacts too as well. In that different societies would have different jargons, different roles for their population, even gender as well. And you have to understand those particular attributes, and then put that in, as Jared said, with education and the continuous communication, and then we can work towards that seamless communication that we all need, particularly in these events, so that we can actually save life and property. Thank you.
Thank you very much. Yeah, I think it really summarizes well that there are so many aspects that come from both the experiences of the past events, but also the educational component in the meantime, and I guess also strengthening the communication and education during the impact itself when you encounter the severe event, the hurricane or the storm, you do have that power of the attention, which also helps to strengthen the bond with the public and stakeholders. Okay, thank you very much for these insights. We'll maybe move to the questions because I'm mindful of the time again. The first question I can see on the chat was for Gerard. And the question is, knowing what you know about the Beryl or other recent storms, are there any areas of the early warning systems or communication that you're looking to improve? So that's the question I can see.
Okay. Of course, the whole idea of early warning and communication is always a living thing. What I would like to see improved also is maybe some sort of legislative framework, so that the powers that be can help broadcast the message and even so get people to act whenever you give information. Okay? That is something that I think could be helpful. But in the Caribbean, as I say, the nations are used to this hazard every year, so there is an inherent level of preparedness. Of course, you'll always find the slackers, but generally there is already an inherent level of preparedness because we face this almost every 6 months. Okay, and so once people know here about a system approaching, the galvanized interaction, okay? So maybe some more legislative framework is something that could probably help with the early warning systems across the region, in my experience.
All right, thank you very much. Another question for Kathy Ann. Could you name an example of the experimental impact products that you are working on and how do you evaluate them? So I guess this is in relation to impact-based forecasting.
Yeah, so traditionally we're using the WMO framework in terms of impact-based forecasting. And what we've done is try to do it on an individual country basis. And therefore, what happens is that country, in introducing the impact-based forecasting to their public, will have ways of distributing either through maps of their countries, of course, using the strategic colorization, internationally recognized colors. And therefore, we look at Barbados, for example. They've been doing that now for about 4 years, and they've continuously going out into the public with out of season workshops, discussions with particular areas, and therefore you educate the public. We're seeing similar initiatives in Trinidad, and we're going to be helping out our colleagues in St. Lucia going forward with this as well. So the experiments are more taking international products and then making them socially relevant in the particular countries. How do we evaluate? Basically getting feedback from the public. Particularly in Barbados, the Barbados Met Service every year has a forum where they invite the stakeholders to come and have a meeting to evaluate what was the progress the year before. And then you learn from those strategies as well. It is actually basically building on what is there internationally and localizing it. And we're finding that this is actually working very well because the public is seeming to be more advised and actually reacting, which is what you want for any impact-based forecasting formula. Hope that answers the question.
We hope that answers the question indeed. If another, I'll bind the two questions together for Evan. One is, what forms of technology have you found most useful when communicating, especially considering the timeliness? But also, I can see that it ties quite a bit with the next question: do you communicate others through Facebook and Instagram? So this is, I guess, also on the kind of technology about the social media use. So we can tie it together, I guess.
Sure. Thanks, Filip, and thank you for those questions. What I find noteworthy is that there are persons who utilize all these media, these various channels. And there are some who will stay with one channel and they will get all their information there and they never go somewhere else. For instance, someone might be familiar with Facebook and is always on Facebook, and there might be someone else who always uses Instagram. So sometimes if we choose not to use particular mediums, it may cause the problem of somebody being left behind or being left out entirely, because that's where they collect their information. So what the best strategy is to see how best we can use all available media. I know that would be a challenge, because especially if you don't have sufficient personnel and the capacity is not there to really get into all of them. Currently, we do use Instagram in the meteorological service, mainly with some assistance from our parent ministry or other ministries that may take over aspects of the disaster management, portfolio. And so they will come in and give the assistance in terms of communicating our messages through these various ways, these communication channels. So it's important that we don't turn a blind eye to any one thing, but we utilize as many as possible. And transparency requires that, because you really want people to get as much information as they can about the real situation. And the more that you're out there, the greater the chance of you being trusted, because they'll see the consistency right across the platforms. They'll recognize what you are saying. You are ready to give them as much information as they need. And then that trust really allows you to be able to not worry about the various other sources of information that might be misinformation or disinformation that could confuse what you are trying to say. So the more that persons do trust you and recognize that you are being sincere in your messaging, then they will basically fall in line and agree and carry your message with you. Thanks.
Thank you very much. I think it also ties together to another question that I can see for Haley. But what I wanted to say is that if you're consistent through all your channels, that also helps people then to carry over that information to their informal networks and to stay consistent with the message, rather than get a derivatives which might not really reflect the situation on the ground. And again, as I've said, that ties back to the question for Haley. Can you name some of the successful informal networks for the rest? Do you have some experience with parallel informal networks? So yeah, I guess to Haley first, but if anybody has comments, we can see that later.
Sure. So I'll just give a quick background in that I worked in disaster management and meteorology, and WhatsApp groups and WhatsApp channels, they have proliferated to a large degree. There are many news stations who utilize WhatsApp channels, and there are many individuals who utilize WhatsApp channels. The challenge for the Met Services is that we can't leave that gap unanswered and allow it to be filled by non-professionals. It would be ideal for Met Services to use that network officially, as I put in the chat, to fill that gap, one, but also it becomes a source for the other ways in which information, for other channels of communication, like WhatsApp and Instagram, etc., etc. So to answer the question directly, the biggest unofficial or informal network is through WhatsApp or Telegram or whatever it is, maybe in your neck of the woods. Thank you.
All right, thank you very much. Does anybody else have any additional comments? Maybe you are using informal channels in your own practice. I don't see anybody else commenting on that.
If I might
okay.
If I might just say, the growth of social media has really taken off, and it is one of the fastest ways to communicate with the population right now, because people want information on the go. So for our service, for example, we have a dedicated team, okay, that prepare these messages, okay? So like all the warnings and so, the data is transmitted via social media plus the traditional media, okay? And it works well. It works well because, as Haley was saying, there are a lot of armchair meteorologists around, and they are quick on the jaw, So we have to fill that gap, and not only fill that gap, but with the authentic information, because The downside of that is that a lot of bad information gets broadcast, and we want to control that as much as possible. Okay, so we try to control the narrative. Okay, so social media has now become one of the biggest industries for broadcasting the early warning messages and as message services. We just have to get with it. The traditional media is there, yes, but the social media component of it has grown in leaps and bounds, and we are forced to move in that direction also.
Right. Thank you very much. One last quick comment from Ivan, and we'll wrap this first part. Yes.
Sure. Just to say that we do have also in Jamaica some informal groupings on the ground that have a number of persons that pay attention to the information that comes out in these groups, and we utilize some of these groups in helping to carry that message. So we do share the message with the leadership of that group, who is in charge of maybe large WhatsApp groups that they disseminate to, and they informally communicate to their stakeholders as well. And that really helps to spread the message very quickly. Thanks.
Right, perfect. Thank you very much. And thank you very much to all of the speakers for this panel, to Ivan, to Gerard, to Haley, and to Kathy Ann. We really appreciate all your insights, and we refer all the other participants of this session to read more in the abstract book. I think it is finalized and published, so please check this out. And I'm sure there's plenty of more information for the future. With this, I announce, I guess, a 5-minute break, and we'll move on to the theme 2 of this session. Thank you very much.
Okay, thank you.
Welcome back, everyone. So we can start with the second thematic block, flood risk and early warning dissemination. I don't want to spend much time introducing why floods are important, but basically they represent 45% of all reported disasters worldwide, and they rank as one of the highest in economic losses and people affected. And no surprise that there were so many abstracts submitted related to floods. We will have 4 talks, roughly 10 minutes for the talks, plus 5 minutes for questions. And we will begin the talks with a recorded talk. Due to time difference, it was virtually impossible for our speaker to join. But we will put the recording by Jinshan Li on behalf of Professor Ziqian Han from Shandong University, who will provide a comparative analysis of major flood disasters in Germany, China, Spain, and the USA. So if we can put the recording.
Hello everyone, my name is Yinshan Li, and I'm so honored to present our study entitled Why Do Early Warning Systems Fail for Extreme Weather and Flood Disasters? A comparison of recent cases from China, Spain, Germany, and USA, which is supervised by Professor Ziqian Han in collaboration with Wein. And firstly, I will walk you through our 10-step early warning framework. We begin with risk knowledge and planning. This involves identifying key hazards, mapping vulnerable populations, and establishing standard operating procedures. Crucially, we coordinate across agencies while maintaining 24/7 operational capacity and standardizing warning information structure for consistent communications. Next is detection and monitoring. This involves 3 core streams: meteorological monitoring for weather threats, hydrological monitoring for floods and droughts, and geological monitoring for landslides and ground movements. Multiple institutions collaborate to create 24/7 comprehensive monitoring network. And next is step 3, hazard analysis and forecasting. Technical agencies integrate monitoring data to produce actionable forecasts using numerical and ensemble models to predict hazard intensity, timing, and location. Beyond traditional forecasting, we conduct impact-based warning design. Every warning contains 6 essential elements: hazard type, expected impacts, timing, location, action guidance, and information source. Step 5 is the decision to issue. Designated authorities review forecast and impact assessment, then decide to issue, upgrade, or cancel warnings. Every decision is formally recorded with justification and assigned responsibilities. Once issued, we move to dissemination. We use multiple channels simultaneously: mobile alerts, broadcasts, social media, and loudspeakers. A key innovation is geo-targeted dissemination, sending alerts only to affected areas to reduce alert fatigue. We also ensure last-mile communication reaches marginalized communities. And step 7 focuses on reception and understanding. The public receives warnings and assesses their risk by checking location and impact information. Understanding bridges information reception and action. So this enables anticipatory action. Step 8. Government agencies and NGOs pre-position rescue teams, prepare evacuation transport, and ready emergency shelters. This creates a response window before the hazard strikes, enabling more organized and safer action. So when the hazard is imminent, we enter protective action. Step 9, the most critical phase. The public evacuates immediately when ordered, following designated routes with essential items only. Agencies facilitate this by organizing assisted evacuations for hospitals and care homes, managing shelters, and conducting door-to-door outreach in high-risk areas. Evacuation maybe is the single most important life-saving action, which is why our framework highlights it prominently. Step 10 is updates and all clear. We issue dynamic updates as conditions change throughout the event. When danger passes, we communicate all clear messages with safe return conditions and begin post-event review to assess what worked. So this brings us to the closed loop in this diagram. We conduct performance reviews, collect community feedback, and update standard operating procedures. These improvements feedback into step 1, strengthening risk knowledge and planning for the next event. So next, I will present a comparative analysis of 4 flood events that occurred between 2021 and 2025 across Germany, China, Spain, and the USA. This infographic synthesizes key hazard characteristics, rainfall metrics, and the socio-economic impacts from these disasters. Maybe these events reveal diverse flood mechanisms, yet similar devastating outcomes, highlighting the critical need for improved early warning systems and climate-resilient infrastructure worldwide. So, using the 10-step framework, we assess each event to identify vulnerabilities and best practices. This heat map shows our findings, with colors ranging from dark green for strong performance to red for critical failures. Let me begin with the positive findings. Steps 2 and 3A show strong performance because Germany and Texas demonstrated excellent detection capabilities, with threats identified days in advance. Next, step 3A, hazard forecasting, was the strongest link. Germany's ensemble models captured extreme rainfall with remarkable accuracy, and Spain issues precise red alerts. Texas correctly anticipated flash flood threats, and even Henan successfully forecasted severe rainfall and issued red warnings. This demonstrates that meteorological science has advanced significantly. However, this brings us to the missing middle, the critical failure zone spanning steps 3B through 7, highlighted by the red dash box. Step 3B, impact-based warning, maybe was universally absent, or for regions scored red. Firstly, Germany lacked impact forecasting for small valleys, and Henan had no risk matrices linking forecasts to metro shutdowns. Spain failed to model which neighbors would flood, and Texas had no systematic tools for assessing risk to specific camps. This gap is critical because knowing heavy rainfall will occur differs from knowing which locations will flood and what actions to take. The next one is step 4, warning information design was similarly weak. Warnings were too technical, lacked action guidance, or arrived too late. And step 5, decision to issue, review severe governance failures. Henan scored 0 because leader failed to suspend metro operations despite repeated red warnings, directly contributing to eternal death. Spain's ES alert reached phones only after deaths had begun, and Germany local authorities hesitated, and Texas operated reactively without pre-agreed triggers. The next step is dissemination. Dissemination also faced technological challenges. Germany lacked cell broadcast system. Henan suffered poor community-level penetration. Timing issues, particularly overnight flooding, severely limited effectiveness. Step 7, reception and understanding. Maybe this was perhaps the most tragic failure. All 4 regions scored red. People continued normal activities, used metro during active flooding, entered underground garages despite warnings, or stayed in place with alerts going unregistered. This cascade of failures created the last mile problem. Scientific accuracy and forecasting became meaningless when it failed to translate into protective action. And the next step, step 8, anticipatory action, was largely reactive. Germany, Spain, and Texas mobilized large-scale rescue operations, but after flooding had begun, rather than before. Henan's late mobilization contributed to metro fatalities. Finally, step 10, post-event learning, revealed important differences. Germany demonstrated a stronger learning capacity, implementing concrete reforms, including mandatory cell broadcast systems and impact-based warning products. Henan also showed significant learning. A state council investigation exposed systematic failures and drove reforms in emergency management and the metro safety protocols. Spain and Texas showed more limited progress, with reforms still in planning stages rather than implementation. In conclusion, this analysis reveals a critical paradox. We can predict hazards excellently, but fail to translate that knowledge into protective action. The universal failure of the missing middle, directly contributing to high death tolls. The key issues are clear: lack of impact-based warning systems, hesitant leadership, dissemination failures, and poor public understanding. So the path forward requires 3 priorities. First, operationalize impact-based forecasting, telling people what will happen to their specific location. And second, establish clear decision triggers that remove ambiguity from evacuation orders. Third, invest in last mile communication that reaches vulnerable communities with actionable guidance. That's all. Thank you for your listening.
Perfect. So now we will turn towards solutions. So I give the floor to Catherine Simmons. If you can start sharing your screen. Catherine is from Nurture Nature Center, and she will be talking about social sciences insights on how to tailor flood forecast products. Catherine? Perfect.
Hi everyone, my name is Kate and I am the Science Director at the Nurture Nature Center, which is located in the United States in Pennsylvania. And I'm going to be talking to you today about our social science research focused on flood risk communication. Our history really poises us to be experts in this field. We've had major flooding in our town of Easton, where the Nurture Nature Center is located, for many years. And that was actually what started the Nurture Nature Center. We developed a community forum model to talk with our local residents and experts about the issue and how we could be better prepared. And we did an education and multimedia outreach campaign in response. That also kicked off our foray into social science research about the flood forecast products and risk communication, because we recognized that there was a gap and a disconnect between the public audiences and then the forecasters who were giving the information that the public needed to know and understand. So we have become a center essentially for studying communication about weather and climate hazards and how to improve it. So the issue really gets down to decision making is complex. There's lots of different decisions that end users are making, and the information that they're getting is also very complex, as you can see here with the range of different products that we have in the United States. And what we do at the Nurture Nature Center is we try to make it more collaborative and iterative and insert social science research early in the flood forecast product design phase, or to help with revising some of those products so that they're better understood and work better within the early warning chain. So we'll do a lot of background research. We'll collaborate with our National Weather Service. We partner with them and the local weather forecast offices that we have in the United States to develop scenarios that are, a major flood event. And we will go and we will test them in focus groups. We've done this across the country, and we'll be able to show them, here's an event coming, here are the products that might be available, what are you doing, how are you understanding this, what are you sharing it, what actions are you taking, what decisions are you making. And we have a graphic designer on our team who actually will change the products, and we'll be able to test alternate variations of that to see if that helps with improving understanding and motivation to take action. And so we can work with our National Weather Service partners to go back and forth to try to make those products be as effective as possible. So our audiences have typically been professional users. So we've done a lot of work with emergency managers and transportation departments, school districts, and other water resource professionals. We also talk with residents. So we'll go out and we'll have focus groups in communities and talk with them about their flood risks and how they're understanding or using the information or not. And oftentimes there is, people who do not even know that they are being served by a weather forecast office and where to get the information. So since 2013, we've actually held 86 focus groups across the United States and have by this time engaged close to 1,000 participants in this research. So what are the types of decisions that we're hearing people are making with this information? They're positioning staff and resources, especially if they're emergency managers. They're determining which roads they need to block. Do they order evacuations? If you're a household head? Are you telling everyone you need to leave, or are you choosing to stay? And then how are you sharing that information? So within all of this, the flood forecast information is very helpful, but there's also the need for probability information, and that can add a certain level of confusion if people are not understanding what the products are communicating, especially in times when key decisions are being made, often in very rapid, high-pressure environments. So one of our first studies looked at probability and how to improve the communication of probability related to flood forecasts. And in the United States, we have this advanced hydrologic prediction service, which includes hydrograph and flood inundation mapping. And I'm showing here an example of the hydrograph. The one in the top is the original one that we tested, and then the one in the lower right is our revised version. You could see that there are many apparent changes. We've made changes to how we actually even describe the probabilities. So it's likely, less likely, least likely, as in the legend there. And we also have this orange box at the top, which is a forecaster's note, so that key information can be given in a very rapid environment. This is another study we did, again focused on probabilities and water levels. You can see it's similar to the one before. We have that forecaster's note at the top, but we have other pieces of information. In this community, they like the least, less, most likely categories, but they also wanted the percentages associated with that. So we have both of those in the legend. We also have this river level exceedance vertical bar chart on the right, which provides additional level of the levels that there would be major, moderate, or minor flooding. And many of these recommendations have actually been transitioned to operation. If you go to weather.nowhere.gov, you can see some of our design recommendations have been instituted in the publicly available version. The current study that we're working on is with our National Weather Service Weather Prediction Center, and they offer a suite of precipitation products that can inform flood forecasting, and this is some of those that we've been testing. What we're focusing on with this project is to really understand where the needs are for the rainfall information to inform preparedness and what barriers there are to sharing that information and understanding it. So we are again doing our approach where we test the original version, but then we'll also test a revised version to see if those design changes help improve the product's understanding. This is one of the products we tested called Excessive Rainfall Outlook, which is showing the risk of rainfall exceeding our flash flood guidance at any point within 25 miles of that location. And you can see we've changed some of the category names and how it's shown, made very clearly what this is showing up at the top and when it is available for. We also were able to test this new product, which is called the Probabilistic Precipitation Portal. And I mention this because it was very positively received. Many people didn't know it existed because it was a relatively new product, but they really loved the ability to have that probability shown in an intuitive way. There's a high-end and low-end ranges that people can choose. They can determine which thresholds they want, how many inches per hour you want to look at, as a threshold. So there's the ability to customize, and it's interactive so you can zoom in. And I mention that because that's part of the barriers that we have seen across all of our studies, is that scale is a huge one. People want localized information. Oftentimes residents will say, well, you said all the cities around me, but you didn't say my city, so I assumed I was okay. So really having that understanding of being local enough to communicate that this is an issue that decisions need to be made. Being able to be understood, actionable, people want to know what this means to them. So simple, clear language, consistency can help avoid confusion, especially in design. And then that customizability is really critical because there's such a range of users and decisions being made that you cannot have a one-size-fits-all product. So some quotes from our focus groups on the right there. It doesn't matter if the products exist if I can't find them. So accessibility is a really huge issue, especially during stressful times where they have to make decisions rapidly. And so what we've learned over the years is we need to make it understandable, we need to make it localized, accessible, and actionable. And so those are really 4 key things that have popped up time and time again in the variety of focus groups and flood situations that we've tested. So really isolate the most useful information, how severe, how long, what to plan, provide that information so they can make decisions. Because in the absence of trusted, understandable information, they will still make decisions, but maybe not the ones that we want them to as professionals working in this field. I'll also note that we have just published a journal article really focused on flood early warning systems, and we've reviewed some more of the barriers and best practices and key characteristics that govern those. That is looking at a global level, not just the United States, though we do have some United States examples there. And so we really focus on that full range of the flood early warning systems. I'm happy to take any questions, and thank you for your attention.
Thank you very much, Catherine. Now we have like roughly 5 minutes for questions, and I see one in the chat. So it says flash floods guidance stressful if there's any plan to adjust that to certain soil type. And yeah, explains his experience on the flash flood guidance product before, but is there any plan to adjust that to the soil type?
It's a good question, yes. So our flash flood guidance product, that excessive rainfall outlook, does take into account local conditions. So it's something that is being forecasted, but also very closely with our weather forecast offices so that they can make sure that it's, accounting for those thresholds that are most critical for their area.
Mm-hmm. Then I have a question when you were saying that part of the warnings need to be actionable. And from the experience in Spain also, one of the main comments is, okay, even if I understand perfectly the warning, I need to go work. And it's not clear to me if I can stop going to work or which are the consequences of it. There was any interesting insight in the focus group that you would like to share?
Yeah, so over the years, we've worked with a lot of our partners about making it more impact-based forecasting, and that is starting to really get traction in the United States. We've done some projects about winter weather, and there's a winter storm severity index that's really based on trying to communicate what the impacts are. So like, this is going to affect your ability to travel. This is going to affect property, or you won't be able to do your day-to-day daily activities. And so that's starting to, percolate throughout our, at least in the United States, how they're communicating about these. So when the local weather forecast office puts out a briefing to their partners and says, this is what's coming up, they will put in, these are the impacts, travel is not advised. Don't think that you're going to get into work today because at least in our area, it's going to be a severe weather situation, and we want less people out on the roads so that we don't have to, get our first responders out there. So that impact-based reporting is definitely, forecasting is definitely a part of the briefings that come out. Obviously, that needs to be tailored to the location and to the specifics of that event that's being forecasted. So it's not something right now I think that we can automate, but it's definitely part of what's out there.
Thank you. There's another question about you working with other weather agencies, either national or international, to improve their own graphics, or is only for NWS?
So I think we would love to work with anybody. If you are interested in working with us, I think our approach is really effective, because a lot of times you might do studies that have findings, but if you're not necessarily able to demonstrate what that actually looks like you need to make such and such a change, it's sometimes hard to conceptualize, especially for if you're presenting to, an agency and you say you need to make this change. They're like, okay, but being able to tell them exactly, like, if you made it look like this and you made this tweak, it just makes it easier to transition to operations. So I think our combination of showing the design and getting the findings together really help with that, transition to operations. So right now we are just focused on the United States, but I think we are definitely open to expanding to other regions as well.
Perfect. Thank you very much. And now we will move into the next talk. So I will give the floor to Jeff Da Costa from University of Reading on the value chain analysis of Luxembourg's 2021 flood disaster. And now we are seeing the presenter mode instead of the main presentation.
You can? Okay, sorry.
No problem.
There we go. Does this work?
Yes, now that's perfect.
Yeah.
Thank you.
Great. Sorry about that. Well, good morning, afternoon, and evening. I'm Jeff Da Costa. I'm in my final weeks of my PhD journey at the University of Reading in the UK. And today I want to talk to you all about one very specific question, namely, why do disasters still happen, even when early warning systems exist? So this presentation is based on our latest publication analyzing the July 21 flood event in Luxembourg. And what I will show you is that the issue was not necessarily the absence of forecasts, it was how the warning system was structured to act. Now, we often treat or see disasters as a surprise or something very unprecedented. And when I say we, I mean us as a society. And that's not necessarily wrong. It's often a reaction of shock to something that is just unbelievable. But the truth is that extreme weather is rarely unpredictable. And forecast models frequently identify elevated risk days or sometimes weeks in advance. Yet large-scale coordination often begins once impacts are already unfolding. And that is really the gap where I am focused on in my research. So to understand this, really, we need to talk about uncertainty. So forecasts are probabilistic by nature. They provide ranges, likelihoods, convergence signals, and so on. But decision systems are very often built completely differently. And they are built around thresholds, binary triggers, activation points, and decision makers in these contexts have a very different set of rules that they play by. And this often creates friction. Now, value chain has been mentioned in previous talks today. So I just provide a snapshot of the values and depth figure that many of you probably know, the warning chain. This has been adapted to include sort of the co-design and the co-production of warnings. And that is sort of central to the paper that we published this year. And I'll go into that in a little bit later. Now, acting early on information means that we have to act under uncertainty but we demonstrate that a lot of systems are structurally just really uncomfortable with that. And this friction becomes really important and sometimes deadly in real events. Now, Dana floods in Valencia have been named, just to name a few, the floods in 21, floods in China, and so on and so forth. So let me show you what this looked like in 21 in Luxembourg. So we have published in NHES our study where we made use of the framework that was sort of one of the deliverables of the value chain project of the WWRP initiative and associated database questionnaire. I was myself involved in that project, and some of the co-team members are also online today, so I would say hi to them at this point. And basically what we did is we traced forecast inputs, institutional interpretation, alert issuance, coordination decisions. Accountability is also part of it, but it's really not about blame seeking. It's really about understanding the system design. And just on a side note, the database will be hosted by the UCL Warning Research Center and should go live next week as they're planning to launch it. Now, what happened in 21? So 21, a lot of talk was about neighboring countries of Luxembourg, so Germany, Belgium. There were a lot of fatalities. In Luxembourg, we didn't really have fatalities. I'm not going into the metrics we use to describe disasters today, but for Luxembourg, it was the financially most costly disaster to date. And it provided a really good opportunity to do this sort of analysis. And basically what we have seen is from July 7th onward, so more than a week ahead of the floods, the ensemble spread increased. And by the 11th, the extreme forecast index exceeded 0.8. So the first line you see on the graph is 0.5, which gives a very high likelihood of an extreme event happening on July 14th. And once it crossed the 0.8 benchmark, it was as likely as confirmation could give. Yet alerts remained at yellow all the way until the day itself of the flood. And once the red flood alert was issued, impacts already began and coordinated action was initiated over 6 hours after that. And public facing sort of press conferences were given in the morning after. So just to link back to Hans' presentation, which is really interesting, is that some of the things that he highlighted for Germany were not necessarily true for Luxembourg, even though they share a border and also tributaries and so on and so forth. So context is really important. Now, what I want to say is, what I want to answer more is, why did this happen? So the disaster was really shaped by how institutional rules defined what counted as actionable information. Probabilistic signals did not really have any procedural roles in the system design. Only deterministic thresholds were authorized, and that at very limited and designated observation stations. And the system filtered risk through three mechanisms: sources that were authorized, thresholds, and the sequence of approval in the different steps, so mandates more. Action followed confirmation, not anticipation. And that led us to develop a diagnostic model that we called the water drop model. Without going into too many details about this, it shows how institutional design filters risk signals. So you have to imagine on the first panel, so A, the blank one, you have a triangle, and within it is the framework. So the system that you're trying to analyze, whether that be a country, a continent, an institution, a service, doesn't really matter, as long as you know what perspective you want to look at. And each triangle has an authorized source, a fixed threshold, and an authority, so mandates. And if one element is missing, action does not occur. In Luxembourg in 21, multiple signals were visible. You can see just on the left-hand side that a lot of them were either completely missed by the system, some were filtered out, some were considered, but in the end not really used. Others were used at a later point. Then you also have the different actors at the different, I don't like to call it stages, but within the different elements of the event and the different time frames. I know it's very small, but at the bottom it basically says years, weeks, days, hours, minutes, and then it expands again to hours and minutes to sort of get away from this cyclical thinking of disasters. But the key insight is really that just because something is visible doesn't mean that it's usable. What does this mean more broadly? Well, again, to answer the initial question, extreme weather is rarely unpredictable. Risk is often identified in advance. We know that. But many systems are designed to authorize action only once formal or procedural thresholds are crossed. But forecasting is probabilistic, and acting early means acting under uncertainty, and that needs something that needs to be embraced and also empowered within systems. But when systems are structured to wait for confirmation rather than anticipation, the vulnerability becomes embedded in the system itself, and that's when we can start talking about a form of systemic risk. So this is the end of my presentation, but if there's one thing I hope you remember from my talk, it's that basically when systems are designed for certainty, they are more likely to deliver warnings that arrive really too late to feel like warnings at all. Thank you very much, and I look forward to your questions.
Thank you very much, Jeff. While we wait for some questions, I wanted something very practical, how it was applying the framework of high impact weather. You know, this template, was it easy, difficult? It was helping you to analyze the event?
Yes, so you have the database questionnaire. I'm not going to lie, my questionnaire is more than 100 pages long, so it is a lot of work. It's what you make out of it, really, but it is a really practical tool that forces each of us to go a step beyond our discipline and sort of to look at an event from different perspectives. And that's how you get such a rich sort of data collection that enables you to do this sort of analysis.
Thank you. Then there's a question by Andrew Tupper. Do you think that the tendency to staff emergency management structures with linear kind of military minds contributes to part of the problem?
Yes and no. I mean, these systems, this linear sort of thinking, they're there for a reason as well, right? Like it's easy to say, oh, you have to be more flexible and everything. But it's like the question that was given earlier, I think by yourself, which was if there is an alert and I understand it, but I have to go to work or don't have to go to work, like this sort of thinking also falls for me under this sort of linear thinking that contributes to the problem. So it's acknowledging that, but it's also making sure that it is that you can implement it in real life.
There's another question by Dwayne Hu. So how do you envision an efficient coupling of forecasting systems and early warning systems? Not an easy question, I guess.
Well, I think the first challenge is really to determine what is the early warning system? What are we actually talking about? So in the case of Luxembourg, it took a whole 100 pages of database questionnaire to figure out what is the warning system in place, and is it an early warning system, or is it just a set of procedures? So that's step number one, which is challenging enough. And then, of course, Coupling of forecast systems. I think, again, depends on the context. You have sometimes hydromet services that are split or put together. Some work better split, some work better together. How they coordinate with each other, I think, is more important than how they stand in like sort of authority.
Perfect. Thank you very much, Jeff. For the rest, if you have any other question, feel free to put it in the chat. I hope Jeff stays with us so he can be answering on the chat if needed. And then I will go to the final talk for Sarah Lindenblov from University of Potsdam on visual hazard communication. So Sarah, if you can start sharing your screen.
Yes, thank you so much, Isadora, for the introduction. I hope you can see my screen. And then I will directly start. Today, I would like to take you to show you some of our insights from a study that we did on exploring visual hazard communication as part of flood early warning messages. So first of all, why should we even talk about this topic? As we already heard that we had in 2021 a really big flood event in Germany, which caused the death of 190 people and widespread damage across Germany, but also Luxembourg and other countries like the Netherlands, for example, or Belgium. And this past flood events revealed that in Germany we do have insufficient early warning messages, apart from dissemination, which was also a really big problem during this event. We also had that people who did receive a warning message were completely surprised by the magnitude, because the magnitude was not well communicated within these early warning messages. So people did not really engage on the early warning messages, and we saw a lack of response behavior. How can we in the future improve this? For example, to not only focus on dissemination, which of course is a super important topic, but also to focus on non-technical measures. One non-technical measure is translating the magnitude and its related hazard parameters. So for example, rainfall intensity or water gauge height into expected impacts, for example, the inundated area or the number of affected households in the form of impact-based warnings. This was also part of Hans' talk already. So impact-based warnings are much more discussed in current research, that they can better translate the magnitude and other parameters for people to better understand early warning messages. Another non-technical measure that we can use is hazard visualization. And with that, we had our research question for our survey: how can visuals be used to clearly communicate the event magnitude? So first of all, which visual cues do we have? If you think about a flood event, you probably think about a flood near your hometown, and you directly have a picture in mind, typically shown in public media. And this is because pictures or photos spark emotional engagement. Of course, that's why they are a great tool for risk awareness and showing the impacts during an event, but they have to already show some impacts to be effective. And therefore, they are typically not used in early warning messages. Secondly, we have symbols or icons. They already link the magnitude to visual information. They are widely used, for example, in the UK. And this is really interesting because they are easily integrated into early warning messages, but of course, they don't show any regional context information. Then we have maps. They show regional context information. They can be an effective tool for communication if they are easily readable, and it has to be clear what is shown inside the map. So for example, is this a prediction map for a certain scenario or for a event which is occurring in the future, in the near future, or this real-time inundation which is already occurring. So with that, I would like to show you some results of our survey. We did an online questionnaire with 1,280 participants, and we gave them a flood scenario with a flood warning message. And we did several rounds of these flood warning messages where we tested generic and hazard-specific symbols and also inundation maps and plain text option. As you can see, we do have 2 event magnitudes. So we have a medium event, which would be equal to around a 50-year return period, and an extreme event, which would be exceeding a 100-year flood event. And with that, we asked them, after we gave them the flood early warning messages, based on the received warning, what would you assess the impact of the expected event? With that, we gave them a Likert scale, so 1 meaning the river will swell, but that is not a problem, and 6 widespread flooding, damage, and life-threatening situations will occur. We expected them to place the medium event with a mean of 4, so somewhere between 3 and 5, and an extreme event between 5 and 6. And with that, we get this matrix. What we see here is, for once, the magnitude event, then the 4 visualization options, and the first number you can see here is the mean of each group. Then we have the standard deviation in brackets and the number of participants within this group. And with that, you can see that for medium events, we actually do have quite a big range between the plain text options, which was the lowest, or which was estimated the lowest mean with 3.8, and the highest for an exclamation mark with 4.5. You can see that the symbols are actually both quite high for the medium event, while for the extreme event, it worked quite well. So the estimation worked quite well to our assumed magnitude. And the inundation map actually was closest to what we expected to see. With that, we can say that we do have a significant influence on which visual cues was used within the early warning message. Maps worked actually best in comparison to our assumed magnitude according to the medium event. For the extreme event, all of them worked actually quite well. And then, of course, we see that the exclamation mark and the flooded house, so the both symbols, were actually quite high, showed quite high means for the medium event. This could be due to the used colors. So as you can see here, we used for the medium event a red triangular, and for the extreme event, we used a purple one. These are the colors also used by the German Federal Office for Civil Protection and Disaster Assistance. So we didn't think about them, or like we wanted to use the official colors. And with that, we actually saw something that was already shown in different studies, for example, by Sutton and Fisher in 2021 and Omar et al. 2024, that people got confused by the color purple, as they expected red to be the most extreme, and therefore we see this maybe really high mean in the medium event. Along with the visual cues, of course, it is super important which kind of information are shown in early warning messages. Therefore, we gave participants of our survey 16 options of typically included information or something that could be included in the future, and participants were able to choose the 5 most important information for them. With that, we have as the 3 most important ones: name of area at risk, so where the flood is occurring, the time of occurrence of the flood inundation and not the precipitation, and of course, recommendations on behavior and self-protection. This, of course, should always be included in any early warning message. Afterwards, we already have maps with the potentially affected area. So maps are much more favored than symbols. This is a really interesting finding here, because symbols scored actually at the 4th last place. Behind symbols, there is the expected amount of precipitation. This is actually an information which is really widely used, especially also in Germany and also in other countries, as early warning messages are often given out also by weather services. Another interesting finding is that on the 2nd last place, we have information on possible impacts, so the damage. This is really interesting because several studies have already shown the positive effect of impact-based warnings. As I already said in the beginning, 2 factors which could be translated for impact are the inundated area and the expected number of affected households. These 2 things are already shown in maps, so we could say that maps may potentially serve as a really good proxy for expected impacts. And with that, I would like to come to my conclusions. So we saw that it's much harder to distinguish medium events. Therefore, it is really, really important to have a clear communication, also in the response behavior, to have according response behavior, and also to give the recommendation on correct response behavior according to the event magnitude. Then second of all, we have visual cues that can translate hazard information. But here it is really important to give out legends, also with simple symbols, and to have not only a national but also an international color scheme. And with that, in the future, if we have an international color scheme, visual cues could also be used to translate the information across language barriers. One really important finding, which should also be included in future research, is the hypothesis that maps could serve as a good proxy for impacts. And of course, there can also be there should be future research, for example, on the factor time, because this is really important for the decision-making process. If maps are the same or give the same results if you have a life-threatening situation. And with that, I would like to thank you. And if you have any questions, you can ask them now or write me an email.
Yeah, there are a few questions. I'm going to skip the first one first, just because your last comment about time. And there's a question about does it still hold true during the event, the result that you're seeing, or the attention and perception of the event alters the perceived risk, and especially when the media is really loud about it. So do you think that you really deserve some time to be understanding how over time the interest of people in different type of signals is going to be changing?
I hope I understood this correctly. So you mean that during an event, the interest in the
between
event
maps and symbols, the difference of the interest in between maps, symbol, text, it could be changing over time while the event is happening.
Yeah, I think this definitely plays a role. People really would like to know where a certain or if a certain area is flooded, where it is flooded. So we do definitely have the shift from predictive maps to inundation maps of already occurring inundation. So this really has to be clearly communicated. I know that a intermediate state is at the moment that different agencies are using symbols together with a polygon to show which regions are probably in danger. This is quite commonly used as, the production of maps is also not as straightforward due to the calculation capacities, for example. But we do have seen a lot of innovation in the last years, so maps are much easier to develop also in short time.
Then the first question we had for you is, was the flood you studied in your studies scenario a flash flood or a longer duration riverine flood?
This was, we actually did several scenarios, so we did not only focus on the visuals. This is only a small part of our study. We also focused on response to timing. But we stayed for this year to compare these. We gave them a time of around 8 hours. So the scenario was written that it was the same timing in all of these warning messages.
Mm-hmm. Then another question is that why did the comparison with past events come in last in the list? And if you think that people don't remember those events accurately, or perhaps they recall it that it was not bad for them or something else?
This is actually a really interesting question. I assume that people might think about really extreme floods. So these are still in our minds. Yeah, the 2021 flood. If you tell them, if you tell someone, okay, this is according to or could be something like the 2021 flood, everyone would know, okay, this is a really severe situation. But for example, for people who went to a new region, who are living in a new region, who, for example, can't remember a flood which was 10 years ago in the media, or a flood that also didn't get as much as media attention, although there were some severe damages, I think this is a factor which is not really understandable for everyone.
Perfect. So thank you very much. There are a couple more questions in the chat. If you can just look at them and give them an answer. Now we will do 10 minutes break and we will come back with the third block of talks.
Great, thanks. Welcome back to the third talk. Isadora, maybe you want to say a few things before we can go into the session? Right. We will now enter the last stretch of the first session. That is the third thematic focus within the first session. And we have 4 exciting talks. All of them focus on a specific theme on risk communication. And this builds very well on what Sarah just talked about, risk communication. But in this particular case, we are going to focus on certain elements that, if put into account, or if taken into account, could support actioning of the communication by those being targeted. And so my name is Gilbert Siame, one of the co-conveners of this session, and I'm based in Zambia at the University of Zambia. The session has 4 speakers. The first one is going to be presented by Charles Ratcliffe from Georgia in the US. And then the second talk is going to focus on John It's going to be given by John from Germany. And then we have a last-minute change by a talk that is coming from the Watershed Organization Trust from India. It's going to be done by Kelka. And we're going to have a last talk by Kaja Shoes in Germany. What will be covered mostly is the importance of language, terminology, concepts, context, and how language can affect literacy, and the possibility of acting upon early warning. And the four papers will discuss the importance of that, how we need to pay particular attention to context, to language. And I think we're coming from a talk that gave us different ways of communicating, using maps, using text, using images. But in this particular case, we're looking at how do you actually package the message in a language that can resonate on the ground, that pays particular attention to contextual factors. And really, these are going to be exciting talks. So without further unpacking, let me request the first paper that is going to look at effects of attributing extreme weather to climate change in risk messages by Charles Radcliffe from University of Georgia. Over to you, Chelsea.
All right, thank you so much. Let me get my screen shared. Okay. Does that look good? You can see it?
Yes, we can see it.
Okay, lovely. Thank you so much. So good morning, good afternoon, or good evening, depending on your time zone. Thank you so much for this opportunity to join you. I'm Chelsea Ratcliffe. I'm an associate professor at University of Georgia in the US, and I study communication. So I run the CUSP lab, which stands for Communicating Uncertain Science to the Public. And a big focus of my work is on identifying effective ways to communicate about uncertain and evolving science. So today I'm pleased to present some findings about the effects of attributing extreme weather to climate in risk messages. My co-authors on this project are my graduate students, Clay Cook and Malek Sabri, as well as Rainer Ramirez Cañas, a behavioral scientist with the Environmental Defense Fund, Marshall Shepard, a meteorologist at University of Georgia, and a professor at University of Georgia, and Wendy Bruin de Bruin, a professor of public policy, psychology, and behavioral science at University of Southern California. And this QR code here will take you to a copy of these slides in case I have to go a little fast through certain parts, and I'll show you this QR code again toward the end. So climate change is strongly linked to an increase in extreme weather events, including heat waves, droughts, strong storms, and flooding. However, it's been challenging to effectively communicate this risk to the public, especially to politically conservative audiences. At least that's the case in the US. Climate change attribution has been found to reduce concern about extreme weather among political conservatives in the US. For example, in another study that our team conducted, we found that Republicans were less concerned about the health risks of extreme heat when they read a message that attributed that extreme heat or linked that extreme heat to climate change. So just attributing it to climate change caused them to dismiss the health risk. So this can present a challenge for risk communication, right? But the link between climate change and extreme weather is important for people to understand. We need to increase public concern about both extreme weather and climate change, and we need to increase public support for adaptation and mitigation policies. Now, it's possible that people's openness to the climate change attribution depends on how it's framed. For example, public responses may vary depending on whether the attribution uses a certain causal claim stating that climate change is contributing to extreme weather events, or a hedged claim, for example, saying that climate change is likely contributing to extreme weather events. Hedged claims acknowledge that scientists can't know for certain whether climate change is the cause of any specific weather event. So it's often more accurate to present a hedged claim, but communicators might wonder if a more concrete claim would be taken more seriously. And it's also possible that the success of communication approaches depends on audience characteristics. For example, some research has found that political orientation can affect responses, such as in our prior study that I just mentioned. And some research has found that direct or indirect experience with extreme weather predicts concern about climate change. So that might also enhance message responsiveness. So these possibilities led us to the current study where we tested the impact of attribution in terms of whether or not extreme weather is attributed to climate change with a certain attribution or a hedged attribution versus no attribution. And we wanted to see if these different attribution frames would affect risk beliefs or support for adaptation and mitigation policies. Our second question was whether political party affiliation or having personal experience with extreme weather, either individually or in combination, moderate the impact of attribution frame on risk beliefs or support for policies. So we randomly assigned participants to read one of 3 message versions, and we developed these based on content from the Environmental Defense Fund website. The messages were about 100 words long, so these are just excerpts. So in the no attribution condition, they read a message that said, extreme weather is on the rise. Scientists are detecting changing weather patterns across the United States, and the trajectory is clear. Hotter heat waves, drier droughts, and stronger storms. In the certain attribution condition, the message said extreme weather is getting a boost from climate change. Scientists are detecting that climate change is fueling changing weather patterns across the United States, and the trajectory is clear: hotter heat waves, drier droughts, and stronger storms. In the hedged attribution message, it read, extreme weather is likely getting a boost from climate change. Scientists are detecting a stronger link between climate change and changing weather patterns across the US, and the potential trajectory is hotter heat waves, drier droughts, and stronger storms. We recruited participants through Prolific. This was last May, and we had a sample of just over 2,000 participants. We set quotas for political affiliation to have roughly equal groups of Democrats, Republicans, and Independents. And to assess their prior experience, we asked 2 questions. One was, in the past year, have you had personal experience with an extreme weather event, such as heat waves, wildfires, droughts, strong storms, or flooding? And the second question, has a close friend or family member had such experience? We found that 62% of the sample said they had had direct personal experience with an extreme weather event in the past year, and 72% of the sample said they had a close friend or family member with experience. So these 2 variables were highly correlated, and they were correlated almost identically with all of the outcome variables. So we combined them to make a single measure for our analyses. And our outcomes were risk belief, so belief in increasing extreme weather, concern about extreme weather, and belief in climate change as the cause of increasing extreme weather. And then policy support, so support for adaptation policy and mitigation policy. And I'll start with a quick overview of our results. So, does a message attributing extreme weather risk to climate change affect risk beliefs or support for adaptation policies? We did find small main effects of the attribution frame for most outcomes, but when we looked under the hood, when we looked at the interactions, these effects were completely driven by certain participant groups. So we found that political party affiliation or personal experience did matter. The attribution frame specifically only mattered for political independents and those without prior experience. So I'm going to try to go pretty quickly through these results here. I know I don't have a lot of time and I want to leave time for Q&A. So basically, we found that yes, let's see, the certain attribution might be less effective for independent. So there in the blue bars, you'll see Democrats, they had a strong belief that it's very likely that extreme weather is becoming more common. And you see that it's the same across the board. And then for Republicans, somewhat likely that extreme weather is becoming more common. You see that's the same across the three message conditions. But for independents, the green bars, you see a slight dip for those who received the certain attribution condition. And this wasn't quite statistically significant, so I'm mentioning that this may be an effect. But we do see statistically significant effects for other outcomes. And then for those with or without experience, we see the purple bar. Those who had prior experience with extreme weather had a stronger belief in extreme weather events becoming more common. And then those in the blue bars had less belief in that, but it was unchanged by the message condition. We see similar results for concern about an increase in extreme weather events, where we see that dip only for independents who received the certain attribution message. Again, not quite statistically significant, so I'll hedge that finding or that claim. And then for those with or without experience, we do see an effect for those without prior experience who received the certain message compared to the hedged message. So again, we see that dip in the middle for those who received a hedged attribution. They were less likely to report concern. And the same pattern emerges here for all of the other outcomes. These, however, are statistically significant. So again, we see that dip for political independence. They think that climate change, they have less belief that climate change has contributed to extreme weather becoming more frequent if they received the certain attribution message. And same with those who didn't have prior experience. If they received the certain message, they reported lower concern. Same story with support for policy, protecting people against extreme weather. We see a dip for independents who received the certain attribution message, and a dip for those who did not have prior experience of extreme weather who received the certain message. And then same story again here for willingness to support policies that stop climate change from getting worse. We see for political independence in green, lower support if they received the certain attribution compared to hedged or no attribution. And again, for those without prior experience of extreme weather, we see less support if they received the certain message compared to the hedged message. So to sum up, I know I've presented a lot of results really fast. Message frame mattered for political independence and those without direct or indirect experience of extreme weather. And this was particularly the case for policy support and belief that climate change has contributed to extreme weather. So this suggests that these groups are still making up their minds about climate change, the independents and those who haven't experienced it for themselves or whose loved ones haven't experienced it. And for those groups, wording seems to still matter, whereas everybody else has kind of made up their mind. And here, the certain attribution frame was less effective for those groups, whereas the hedged climate attribution frame was either superior to or on par with a no attribution message. So the fact that there were no negative effects of a hedged climate attribution message for any audience group, my colleagues and I thought that was actually quite an encouraging finding in and of itself. So past research found that backfire effects of attributing extreme weather to climate change have been the case in the past, including some of my research, but maybe that's fading if more political conservatives are accepting climate change. So beyond being a more realistic depiction, we wonder, could there be other reasons for a hedged attribution to be received more favorably by certain groups? And we'd certainly love your input on this. For example, could it be that this hedged attribution lets the movable middle continue to not make up their minds about climate change, and that's why they preferred it? And certainly more research needs to be done to assess generalizability. So effects were relatively small and based on a single message adapted from the Environmental Defense Fund. And it will also be important to see whether our findings apply to warnings about specific weather events rather than extreme weather in general. Another question is whether effects of prior experience diminish over time, since we only asked people about the prior year, and maybe effects of prior experience compound as somebody has more of those experiences. So these will all be very important to look at going forward, but we'd really love any questions and feedback that you have for us. Thank you.
Thank you very much, Chelsea. Very, very rich insights there. I think we'll move straight. I have a question that you might think about, which will come. I have a question on how best then can we balance in our communication between probability and uncertainty in order to sort of reach everybody and minimize the risk of damage, even when we operate in a very fractured real world, like the one you have just described. It's the same in other parts of the world: opposition politics, ruling party politics, voters, non-voters, and all that, and religion and other factors. So how can we package and communicate in a manner that will reach everybody? That might be very difficult, but it would be nice to hear a reflection on that.
That's the number one question. I don't know if our study speaks to how we can package a message to reach everybody, but one thing our study seems to suggest is that if it's accurate to hedge information, then going with that accurate portrayal, that where you're acknowledging uncertainty, seems to be kind of a universal best approach. So for those who seem to have already made up their mind in this polarized context, the Democrats, the Republicans, those who had prior experience, there was no message frame that had any effect whatsoever. So nothing was off-putting. But for those who were still forming an opinion, the hedged frame performed best, and that might simply be that people tend to understand that some uncertainty is inherent in science, and so they saw that as more accurate. So it seems like just being accurate and conveying the uncertainty that's there is the best way to go. But there are fewer studies that have looked at communicating probability, which you mentioned, and it's not clear if people understand probabilities, like numerical probabilities, as uncertainty, or to what extent they see that as similar to a hedge. I think that's maybe a future direction.
Great, thank you so much. I think we will move to John. John, are you able to make your short presentation on improving weather risk communications, effects of spatial resolution, and focus format on perceived risk?
Right. Just a second. Well, I'll try to share my screen. Okay, this should work now. Yeah, thank you, and guten Abend from Berlin, Germany. I'm John Gubernat. I'm a PhD student in psychology, and I'm gonna present our results on the effects of spatial resolution and forecast format and perceived risk. And to start off, I'm going to briefly talk about why it is important to look at meteorological forecasting from a social scientific perspective, and I'll do so in the context of extreme weather. People may use different strategies to make decisions based on probabilistic information. Oftentimes they rely on what we call heuristics, and these are basically rules of thumbs, and how exactly people get to their decisions can differ from individual to individual. And this means that simply providing information does not necessarily lead to desired behavioral outcomes. Now, when we talk about extreme weather events, there's one major problem, and that is extreme weather events can potentially have very severe impacts, but usually come with very low forecast probabilities. And we know from psychological risk communication that events with high impacts but low probabilities pose a problem. And that is because low probabilities do not always spur people into action where it would make sense to engage in protective behavior. There are certain thresholds of around 40 to 50% likelihood from which people get active. And yeah, that points to a problem that is already well known of, for example, in other fields like medical risk communication, namely that low probabilities are oftentimes not taken seriously enough. And one possible solution that forecasters might have at their disposal is lowering forecast resolution and thereby increasing probabilities. You can see here at a forecast map for likelihoods of forecasts or for wind speeds exceeding a certain threshold, that with lower spatial resolution, the probability of that threshold being exceeded is getting higher. But at the same time, also spatial uncertainty increases. So the precision of where exactly the event occurs, if it occurs, gets lower. And as you can see here, this is just a schematic overview. On the right-hand side, with the neighborhood forecast on the very left, you can basically say, okay, the likelihood of me personally being affected is very close to the forecasted probability for the entire neighborhood. Whereas if you get the probability of, let's say, 40% chance of heavy rain at any point or somewhere in the whole city, that probably deviates from your personal risk to be affected, as if it rains at a completely different part of the city that doesn't affect you. And the key question that arises for us here is which spatial resolutions are the most effective for communicating probabilistic forecasts and warnings. And we want to investigate, given different resolutions, how that affects the perceived personal risk, how that affects the trust in forecast and the perceived usefulness, and whether there are individual differences, so which users are more likely to misinterpret forecasts. We did this by conducting an online experiment, collecting two samples. One was a general public sample representative for the German population in regard to stage, age, gender, and education. And one was an expert sample, 77 experts from the German Weather Service, basically our objective baseline on how the risk should be perceived, given the information that we provided. And there were three key characteristics of our study. One was that we used real forecasts for severe wind gusts, varying in spatial resolution and forecast probability. And the second was we varied communication format. So we used numeric descriptions of probability in forecast region and compared this to including also forecast maps. And thirdly, we looked at the influence of structural changes in probability distributions and forecast maps through aggregation. What do I mean with this? You can see two different levels of this on this slide. On the top row, you have maps that remain somewhat stable across spatial aggregation. So aggregation leads to minimal changes in the structure and distribution of probabilities, whereas on the lower row, you see from high to low resolution, substantial changes in the structure and distribution of probabilities. So where if you start out with very spotted points or areas, active areas in the high probability map, those gaps between the active cells basically get closed through aggregation and form larger clusters, and in the end result in a big blob of quite high probabilities with low resolution. Now, we used mixed methods. As I already mentioned, we had different communication formats, and we varied this between subjects or between groups. One was the numeric forecast only, then numeric forecast with plus an additional forecast map with color scale and minimal changes, and the third group was receiving forecast maps with that color scale and substantial changes. But we also varied something within subjects. So every participant in the experiment received a total of 12 forecasts varying in three different levels of spatial resolutions, from high to low resolution, as you saw before, and 4 levels of forecast probabilities for the area surrounding the participant's location. Let's look like that. So this is an example for our experimental trial. You see the numerical description on the left-hand side. So this is what everybody saw. And if you were a participant in one of the conditions receiving additional forecast maps, you also received the map displayed here. So providing spatial context and a color legend on the right-hand side. And for every forecast, we asked, how likely is it that your location will be affected by a severe wind gust? So we did this 12 times, and all of those forecasts were regarded to be individual and from each other. So people wouldn't make assumptions based on the resolution and the other maps that they saw before, that they were belonging together, and made individual judgments based on just the information they saw at this moment. And I'm gonna jump straight to the results. So on the top row, you're gonna see the results for the general public, and the bottom row for the experts. On the x-axis, you see the forecast probability, and on the y-axis, the perceived personal risk. And in the 3 columns from left to right, you see the experimental conditions or experimental groups. So numeric on the left, map stable in the middle, and map change on the right-hand side. And this is what we found. I'm going to start with the experts because they responded as we expected them to. So you can go from light colors to darker colors for high resolution to low resolution. And you can see within every level of forecast probability, you have higher perceived personal risk for the high resolution forecast and lower for the low resolution forecast, meaning spatial uncertainty lowers perceived personal risk, and did so also in all 3 conditions. We found stronger effects for higher probabilities. So with 80%, for example, with the numeric condition over here, you can see the effects are stronger than with 20% forecasts. We found the same effect for the public sample in the numeric condition. You can see here, people get low with a perceived risk when spatial uncertainty increases, but in contrast to our expectations, this effect didn't really appear for participants who additionally to the numeric descriptions received forecast maps. So in essence, the forecast maps eliminated this effect. And yeah, surprising finding, and in comparison to the experts, also something that should not happen or should not be or is not the objective correct interpretation of the forecast probability in comparison to the spatial reference. We also looked at the other psychological variables that influence risk perception and behavior. So usefulness, trust, and support for probabilities in general. And we asked, how useful do you find each of the 3 forecast region sizes for your everyday life from a scale from 1 to 10? And how much do you trust the forecast depending on region size, and if weather warnings should additionally include probabilities to simply deterministic descriptions. And here we found for usefulness in the left column, higher resolution led to high perceived usefulness, and the lower we got with the resolution, the lower the usefulness. And this was found across all 3 conditions and for both the public and the expert sample. And with trust, this was also the case for the public sample. So the lower the resolution, the lower the trust. So you can say basically you don't have the spatial uncertainty forecast probability trade-off. So basically with lower resolution, the probability is getting higher and the risk getting lower. At the same time, the trust is affected by it. So yeah, lowering the forecast resolution as a tool is something that should be regarded with caution. We found overall high support for forecast probabilities being included in weather warnings. And this was across all three conditions. And with this, I want to thank our collaborators and from the German Weather Service and everyone on the RERESCOM team. If you have any more questions or notes on the study, feel free to contact me on this email address, and I'm also now happy to answer any questions. Thank you.
Thank you. Thank you so much, John. Just a quick one that I'll read from Amy. She says, do you have any forecasts in your study where participants were near the boundary of, but not within a predicted impact location of one of the maps, or near a boundary of probability categories? You can read that.
Yeah, let me see if I get this correctly. Near the boundary of, but not within a predicted. Okay, yeah. We did not test for that. We thought about looking at the influence of surrounding cells, or we actually looked at the influence of surrounding cells, and usually or basically for all of our forecasts, the best predictor of the perceived personal risk was the forecasted probability at location. We looked into the possibility of basically spillover effects or other probabilities on the map, but didn't find any influences there. We excluded zero probability forecasts, also because we figured, okay, if we only present a numeric forecast, people would not differentiate between the resolutions in any case.
Excellent.
If this answered that.
Sure. Thank you. Thank you so much. We move to, I think, a third presentation by Kelka on community-based disaster management, a participatory approach to enhancing preparedness in semi-arid regions. Over to you, Kelka.
Yeah. Hello. Can you hear me?
Yes.
Yeah. Thank you. Yeah. Thank you everyone for joining this conference, and we really appreciate the opportunity. So I'll be presenting this study on behalf of our colleagues. They couldn't join us for this session today. Can you see the screen?
Still coming? Yeah, we can see it.
Okay.
Good.
Okay. I'll start now. Hello everyone. My name is Saurabh Kedkar. I'm a climate researcher at Watershed Organization Trust, and I'll be sharing this study on behalf of my colleagues. Rather than a technical study, I'll be sharing it as the story of how the participatory approach to enhancing preparedness in semi-arid Maharashtra led to disaster risk reductions in those regions and how it enhanced the rural resilience in the particular region. So a little bit about the organization. We work on watershed development and climate adaptation for resilient rural communities in semi-arid regions of India. This particular study was part of the Climate Change Adaptation Project. It was in partnership with the National Agriculture Bank for Rural Development NABARD and the Swiss Agency for Development and Cooperation. And it particularly focuses on resilience in vulnerable communities. The goal of this study was to bridge the disaster risk action plans, which are often quite technical, but as long as they translated into the language that the community understands, the local decision making can maximize the impact of those action plans. So the goal was to bridge the technical aspect and the community understanding. Climate risks are nothing new for us now. Increasing frequency of heavy rainfall events and prolonged dry spells during monsoon are more frequent now. They have impacts on agriculture, water availability, both for drinking purposes as well as agricultural purposes and corresponding livelihoods. So we need a timely and understandable climate information at village level. However, often the weather forecast and the climate projections that we have at our hands today, due to inherent model uncertainties and structural differences, we often do not get precise information necessary for village level adaptation. On the other hand, even if we get very high resolution forecasts, those are often technical and inaccessible to the villages or the local communities. And they often lack the integration with traditional knowledge systems. We have our own disaster action plan, but the community, they have their own understanding of the local ecosystem and local weather patterns, so the local climate and how it has evolved over the years. They have their own knowledge. They have their own ways of mitigating the risks. However, with the changing climate patterns and altering weather systems, those traditional systems may not be solid in the current system. So during this project, we developed a village-level disaster management clock. It is a DRR tool to communicate weather-related risks clearly. It's a simplified risk mapping exercise for the villages, and it takes into consideration vulnerability assessments for agriculture, water, and livelihoods. It also has structured community dialogues for awareness and planning. So whenever we take technical information related to disaster risk, we can structure it in a way the community can understand. They can get aware about it and take the action accordingly. So I'm sorry, most of these photos are in regional language, but I'll try to explain as much as possible. So there are 4 phases of the clock: the prevention and mitigation, watershed work, soil and water conservation related practices, then preparedness, the mock drills in case of disaster strikes, awareness about disasters and the early warnings provided by the weather forecast and weather forecasting agencies. Then how to respond to these risks, the evacuation plans, locations of the safe shelters, and the coordination while evacuating. And what are the recovery options? What are the recovery phases? What are the livelihood restoration, the infrastructure repair required post-disaster? Now, the benefit of this clock is like it's visual and quite easy to understand. It is in the local language where people can understand it, rather than technical terms that we use in weather forecasting and disaster risk reduction practices. It links seasonal risks to action planning and helps villages decide what to do and when to do. So this particular figure is for rainy season, but we have developed the same clock for the summer, for winter, even also the transition period between the seasons. Now we have developed the tool, but how to implement it? We implemented in selected villages in the states of Maharashtra and Madhya Pradesh in India, in collaboration with the government agencies for timely disaster risk advisories. However, when we are talking about rural resilience, the community's participation is the most important, crucial aspect of the whole plan. If the community is not totally involved, then we might get the results as long as the project duration lasts, but those results might not be sustainable once the project completes. If the community is aware of the risk and how those risks impact their daily lives, livelihoods, for them, for the next generation, as well as for the community as a whole, the impact of the risk reduction plans maximizes. Now we have our own terminologies, we have own definitions and the way to share the weather or risk related information. However, if community often don't understand those terminologies, it's difficult for them to understand what probability means, what chances mean. They only want to know if whether it's going to rain or it's not going to rain, whether it's going to help for the agriculture practices, whether it's not going to help. So communicating through a way in which they can understand is essential. So we approached a certain ways on how to communicate this risk. One of those ways was to using a street play or a skit where we planned a short street play showing how what to do when a disaster strikes with the reference of disaster clock in the background. It actually helps community understand the technical clock or the disaster clock even much better. So what were the outcomes and the impacts? It led to improved understanding of climate risks on the communities and led to co-development of actionable DRR plans at village levels. It develops stronger linkages with government systems for early warning purposes. In this figure, we can see one of the villages identifies one of the risk zones on the map that we prepared for that. The map includes what were the stream channels, where were the electricity grids, where were the hospitals, and which were the vulnerable zones in that particular village. In addition to that, we also shared emergency contact details of the government agencies as well as the personnel, so the electricians or the doctors or the pharmacists at the locations which are accessible to all the villagers. This particular image, it shows the what to do and what do's and don'ts during a thunderstorm and lightning strike. So in addition to emergency contact details of local administration, these kind of infographics and things to take care in case of a lightning strike or the thunderstorm events really helps them prepare for their own daily activity. So what we learned is that participatory tools increase the trust and adoption. As long as the community is experiencing what we are showing them in a way that they understand, they are willing to accept it. Otherwise, often the information that we are trying to share, or even though we have very good intention of rural resilience, as long as if the community is not aware of it or do not understand the benefits of it, the purpose of our efforts do not often go across what we intended. In addition, the local knowledge enhances relevance of climate information. Now, we have our charts, we have our data, we have our forecast for the next 3 or 5 days, but the local knowledge, the community has better understanding of how system works in that particular location. And integrating that knowledge with the forecast and disaster related plans, it really helps enhance the effectiveness of those plans. As the institutional linkages are essential in these kinds of instances where the timely advisory is crucial. Now, we have seen that the DRR tool reduced the vulnerabilities through informed engagement. It integrated weather risk communication into local development planning. It really helped community understand what we're trying to do and what benefits are there in the structured action plan. So the way forward for this for us is like scaling the tool to more regions and strengthen evidence-based resilience strategies. In this photo, you can see we have written "Be alert" on the riverside rock. So that rock often submerged during the flooded situations. Beyond once the water level goes above that rock level, it gets hazardous to the nearby communities. So that's all. If you have any queries, please let us know. And thank you.
Perfect. Thank you. Thank you very much, Koka. we will move to the third one. But before that, I would just like your quick reflection on the importance of using local language to communicate the early warning or the evidence to the community. Typically, people start or projects talk of integrating lived experience, local knowledge, indigenous knowledge, but we tend to start these things in English or in some other language. So in your case, it looks like integration is important, but how did your project go to an extent of actually localizing the scientific evidence in the local language so that it is better understood? Just a quick reflection on that.
Yeah, sure. So often we have our technical terms for disaster. For example, for floods, we have terminologies related to flood inundation, flood duration, those kind of things. But in local language, they have their own way of understanding. In per se, we have to translate in a way in the terminologies that they understand. So if, for example, in regional language, in Maharashtra, a flood is called as poor. It's called poor, not poor. And if we go and discuss about floods in the region and say we are here to share information about floods, they're not going to understand it. But if you're going to say we are going to share what would be the risk of poor in flood, so that kind of gets our point across what we're trying to convey. So in our cases, translating the technical terms into the language that local people understand, it's often the spoken language. They have their own way of understanding the nature and the ecosystem surrounding them. And when we approach communities in such cases, first we often have to establish a contact within the community to understand what exactly the local knowledge is. First, we have to understand that, and then only we can translate our own findings in a way that they will understand. I think that.
Yeah, thank you very much. Thank you. We have a few minutes at the end of the session, but a great answer indeed. Let's move to the last presentation by Keja. Care from German on evidence-based terminology for thunderstorm warning phases, about phase naming study in German. Good.
Hello, and thank you for joining. Today I present findings from a large-scale study on warning phase terminology in Germany. The study was conducted as part of the Vexicom project funded by the Hans Ertl Center for Weather Research in collaboration with the German Weather Service Rainbow program to develop a new weather warning system in Germany. Research and risk communication shows that warning terminology directly shapes risk perception and behavioral response. Multi-phase warning systems are internationally encouraged because they aim to provide clarity and actionable guidance through clearly differentiated stages. Different approaches exist for structuring these systems, for instance, along dimensions such as severity levels and temporal phases. Our study focuses specifically on the temporal phases, which are designed to mainly communicate uncertainty and lead time as an event approaches. The idea is that structured alert levels mirror how people perceive escalating risk, helping them make timely and proportionate decisions as certainty increases. For tiered warning systems to work, terminology should reflect phase-specific characteristics, such in our case uncertainty and time horizon, but terminology should also be clear and intuitive, so the public should understand the labels without further definition or explanation. Furthermore, the terms and faces should be related to certain behaviors. While multi-phase systems are widely promoted, there's actually no consensus on fundamental design questions such as number of faces. Also, terminology is often interpreted inconsistently. For example, studies show confusion between the terms watch and warning in the US system. Existing literature emphasizes that effectiveness depends critically on cognitive processing, so on how terminology aligns with users' mental models. Yet, public understanding, particularly in Germany, remains largely untested. Therefore, our objective was to empirically investigate which phase structure, namely number of faces, and which terminology are most intuitive and behaviorally meaningful for the German population. Today, I focus on the results related to the latter aspect, so on terminology. We conducted a nationwide online survey with 1,050 participants using quota sampling for age, gender, and education. Participants evaluated 9 different labels across 4 temporal phases. These phases map onto increasing certainty and decreasing lead time. Warnings progress from phase 1 through phase 4 with Warnung representing the established warning term in the German system positioned at phase 3. We measured semantic interpretation across 5 dimensions, including, for instance, certainty, lead time, and warning stage attribution. We also included comprehensibility. Furthermore, we measured explicit preferences using open-ended questions, so the participants were able to generate terms themselves. And they had the option to select from the 9 warning phases we introduced. Additionally, we included an experimental component to test whether different labels influence threat perception and behavioral intention. So what did we find? For example, this heat map displays temporal interpretation of the warning labels we tested. If labels were clearly understood according to the phases, we would expect each term to be strongly associated with one specific time category. However, what we observe is substantial dispersion. Most labels are spread across different lead times. Only Akutwarnung, which could be translated with acute warning, and to some extent alarm, show clear and consistent mapping to one phase. We observed similar patterns across other dimensions such as certainty and, as you can see here, warning stage attribution. We asked participants, which word do you think best fits the following statement? Thunderstorms are visible, are expected, or are possible. As we saw before, most labels are spread across the warning stage associations, except of Akutwarnung and alarm. So this indicates that semantic label differentiation is limited and overlapping for most phases. Even more striking, participants show internal inconsistencies in their preferences. For example, based on their semantic interpretation, many participants sought Vorwarnung, which could be translated into pre-warning, into phase 2, but not phase 1. But when asked directly which term they prefer for phase 1, many still chose the the term Vorwarnung. Also, some respondents initially indicated that a certain phase should not be labeled warning, but in the next question selected Warnung as their preferred term. So, in other words, what people prefer is not necessarily what they understand best. How does that matter behaviorally? We tested this using a randomized between subjects design with 9 conditions, 1 for each label. We measured, amongst other things, intended protective action. As you can see, we found no significant differences in behavioral intention across labels. All labels produce similar responses clustering around the midpoint of our scale. However, when we manipulated contextual information, such as lead time and certainty, we observed clear and substantial differences in behavioral intention. Participants showed significantly higher protective intentions when warnings indicated short lead times with high certainty compared to longer lead times with high uncertainty. This contrast is crucial. Behavioral response is sensitive to contextual meaning, but not to label variation alone. So, taken together, our findings should suggest that terminology alone is insufficient to structure public response. Semantic differentiation is limited. Preferences are internally inconsistent. Particularly, we saw that what people prefer isn't necessarily what they understand best. Also, label variation alone does not influence intended action. Contextual information, such as lead time and certainty, drives behavioral response far more effectively than the labels themselves. So, if warning systems aim to structure public response, they must do more than rename phases. They must structure meaning. Thank you, and I look forward to your questions.
Great, thank you so much. So, very, very important. And I think the last paper ties it very nicely to the entire conversation for the day. The text, warning, visuals may not be adequate. Creating meaning is important. And this speaks to the keynote during the opening, that we need to strive towards meaning creation in order to inform action. And that requires us to think about the importance of context. The paper by Charles clearly shows that local factors like political affiliation in other contexts could be religion, in other context could be access to resources or income. All those local factors play a very critical role in shaping how early warning is received. There is just one question, and it's sent to Kelka on whether the work you've presented has been published anywhere or it is still work in progress. Could you clarify on that, Kelka, please?
Yes, it's not published yet, but we have documented it, and we can share it if anyone's interested in knowing more about it. Or I have just shared an email address. Please feel free to drop a message to Abhijit. He was supposed to present, but he couldn't join. So please feel free to drop a message to him.
Perfect. We've taken note to take note of the email, and I'm sure the Secretariat will get in touch in order to share the resources that are coming from this session. I don't see any question, but we can have a minute if there's anyone who would want to ask before I hand over to Isadora. Is there any question? Anyone would want to speak? We can give ourselves at least 1 minute.
Hi. Kathy and Caesar from CIMH. Just one quick question to any of the last 3 presenters. in terms of their surveys, particularly the one on demographics for the U.S. Was there a use of educational base of the samples? What level of education that they were when they looked at these samples, was that embedded in their research? I just wanted to know that question, because it seems like there was a lot of technical language sometimes, even though you want to bring it down. Was the public, in some cases, there was some results that said the public getting more knowledgeable, but I wanted to know, was there a basis, a foundation in terms of the education that was embedded in the surveys? Thank you. I hope that was clear enough. Thank you.
Yes, thanks. Maybe Chelsea can take that on what you presented on education and knowledge levels.
Yeah, I'm so sorry. I didn't quite follow the question.
Oh,
So the
okay.
question,
Yeah, sorry, in your research, did you have in your questionnaires, was there a link to the basic educational level? That might be the best, simplest way to put it.
We didn't find a main effect of education on any of the outcomes, but somebody in the comments suggested that we look at whether effects might have varied by education level within the political independence group, and that's something we hadn't done, and so we'll certainly plan to look at that.
Thank you very much. Really great presentations all.
Thanks for your question.
Thanks. So we're out of time. Let me hand over to Isadora to wrap it up, and then we close. Over to you.
Thank you very much, Weaher. And thank you all the participants, especially those of us in Africa and Europe, that we are in a very late time zone and staying with us. I think it has been a great conversation, a lot of discussions, and yeah, we are very thankful to all of you. And now I would like to, if we can share some slides just to wrap up. There are some announcements. I think most of you probably got it through the generic email of the conference. There is a collection of papers right now ongoing on weather and climate-induced multi-hazard futures, and it includes forecast, communication, and preparedness for society. So not only for the presenters, but also part of the audience, if part of your research is touching communication and you think it can be interesting, please consider putting all these together. It's not only for weather and society, it's a broader collection of papers, but it's quite related to the topic. So we encourage you to have these, because there are not going to be actual proceedings of the conference, but any published paper on a lot of this very interesting research will be very interesting. That's on one side. The next slide. Inside the SERA working group, we launched a few weeks ago a survey on social sciences capacity and experiences at meteorological, hydrological, and geological institutes. We are quite mindful, quite a lot of you are on the social sciences part, and this survey is looking for your experience working. For those of you that work in meteorological services, but also all of you that are working on research or other research institutions that are working closely with these services, is just to understand this link and this connection between natural scientists and social scientists and how is this working. So please take note of the survey, scan with the QR. Anyway, we will be sending a summary email at the end of the conference with some of these links, but please, we are really looking forward for all your inputs and your knowledge. And then the last thing is that this is the first session. We're going to have other 4 more, but we are also mindful of your time. Not everyone can attend all of the sessions. If this is the only session that you're going to be able to be listening and attending, then we really would like your feedback. We would like that you give us your feedback on how the session was going. What do you think about the conference and the format? There are a number of questions. It's not very long, but it will be very useful. So we keep improving over the sessions, over the next editions. If you're going to be coming to other of the sessions, no need to answer today, just wait until the final one. We will be sharing these links also in a wrap-up email at the end of the conference. And last thing is that the whole conference is going to be recorded, and a few weeks after the conference, we will be publishing the recording of the session. So we will not be sharing the slides on itself, but you will be able to go back to many of these interesting talks and share with other colleagues if you think it can be interesting for them. Thank you very much, and thank you for your time and being with us. Good night, good morning, good evening, wherever you are.